What if I told you that the moment you just experienced is already dead? That the now you think you're living in doesn't actually exist? That time, the most familiar thing in your life, might be the universe's greatest illusion. Right now, as you read these words, photons are striking your retina at the speed of light. Your brain processes them in about 80 milliseconds. By the time you become conscious of this sentence, it's already 80 milliseconds in the past. You have never, not once in your entire life, experienced the present moment. You've only ever lived in the past, a fraction of a second behind reality itself, forever chasing a now that slips away before you can grasp it. But here's where it gets strange. According to the laws of physics, that past you just experienced, it still exists. Right now. Somewhere in the four-dimensional fabric of space-time, and the future, the one you think hasn't happened yet. It might already exist too, laid out like a landscape you simply haven't walked through yet. Time, as Einstein discovered, doesn't flow. It just is. For over a century, physicists have known something that most people find impossible to accept. Time is not what it seems. It doesn't move forward in a universal stream carrying everything along with it. Instead, it bends, stretches, and even stops depending on how fast you're moving and how deep you are in a gravitational field. Near a black hole, time slows to a crawl. On a speeding spacecraft, clocks tick differently than they do on Earth. And at the speed of light, if you could somehow reach it, time would stop completely. This isn't science fiction. It's been measured, tested, and confirmed thousands of times. GPS satellites orbiting Earth right now have to constantly adjust their clocks, because time runs faster in orbit than it does on the ground. Without these corrections, your navigation would be off by miles within hours. Time dilation, the warping of time itself, is not a theory. It's an observable fact woven into the technology you use every day. But the mystery goes deeper. Because while we can measure time, bend it, and even slow it down, we still don't know what it actually is. Why does it only flow forward? Why do we remember the past but not the future? And most disturbingly, if the laws of physics work perfectly well in both directions, forward and backward, then why can't we travel backward through time the way we travel backward through space? The answer, it turns out, might have nothing to do with time at all. It might have everything to do with entropy, the universe's tendency toward disorder. Every cup of coffee that cools, every star that burns out, every memory that forms in your brain marks the arrow of time, the one-way street from order to chaos. But entropy doesn't explain why time moves. It only explains why it appears to move in one direction. So what is time, really? Is it a dimension like space? Just another coordinate in the fabric of reality? Or is it something more fundamental? Something woven into the very structure of causality itself? And if time is an illusion, as some physicists now suggest, then what are we actually experiencing when we feel time passing? Tonight, we're going to explore one of the deepest mysteries in all of science. We'll trace time from its birth at the Big Bang, when the universe's clock first started ticking, to its possible end in the heat death of the cosmos, when every clock in existence will finally stop. We'll examine the strange experiments that prove time can run backward, the mathematics that suggest time travel might be possible, and the disturbing implications of quantum mechanics, which seems to suggest that time doesn't exist at all until someone observes it. We'll look at closed, time-like curves, regions of space-time so warped that they loop back on themselves, potentially allowing travel to the past. We'll explore the twin paradox, where one twin ages slower than the other simply by moving fast enough. We'll dive into the block universe theory, which suggests that past, present and future all exist simultaneously, frozen in a four-dimensional structure where free will might be nothing more than an illusion. And we'll confront the possibility that time isn't fundamental at all, that it emerges from something deeper, something stranger. Quantum entanglement, perhaps, where particles separated by vast distances seem to communicate instantaneously, defying the speed of light and suggesting that time and space might not be as separate as we think. Or maybe time is just the way conscious beings like us perceive the increase of entropy, a trick of perception that helps us navigate a universe where cause must always precede effect. By the end of this journey, you might find yourself questioning everything you thought you knew about reality. Because if time isn't real, if it's just an artifact of consciousness or a dimension we can manipulate like space, then what does that say about your memories, your plans, your very sense of self? If the past still exists and the future is already written, then are you really making choices, or are you just experiencing a predetermined sequence of events? The ancient Greeks believed time was circular, that history repeated in endless cycles. Eastern philosophers speak of eternal return, where every moment has happened before and will happen again. Modern physics, strangely enough, is starting to suggest they might have been onto something. In the quantum realm, particles don't seem to experience time the way we do. They exist in superpositions, being in multiple states at once until observed. And some interpretations of quantum mechanics suggest that the future can influence the past, that effects can precede causes, that time itself might be bidirectional at the smallest scales. This is not a comfortable idea. We build our entire lives around the arrow of time. We plan for the future. We remember the past. We live in what we call the present. But what if all of that is just a story we tell ourselves? What if time, the most fundamental aspect of your existence, is the universe's most elaborate illusion? So take a deep breath, because tonight we're going to pull back the curtain on time itself, and what we find there might be far stranger than you ever imagined. The nature of time, the arrow that points nowhere. Let's begin with something simple, something so obvious that you probably never questioned it. Time moves forward. You were born, you grew up, and one day you'll die. Eggs break but don't unbreak. Coffee cools but doesn't spontaneously reheat. Rivers flow downhill, never upward. The universe, it seems, has a direction, a one-way arrow pointing from past to future. But here's the problem. The fundamental laws of physics, the equations that govern everything from atoms to galaxies, don't care which direction time flows. Newton's laws work perfectly well forward or backward. If you filmed a planet orbiting the sun and played the video in reverse, the motion would still obey all the laws of physics. Same with Einstein's relativity. Time can run forward or backward in his equations, and the math works out identically. This creates one of the deepest puzzles in physics. If the laws of nature don't distinguish between past and future, then why does the universe? Why can we remember yesterday but not tomorrow? Why do we age instead of growing younger? Why does entropy, the measure of disorder, always increase? The answer, according to most physicists, lies not in time itself but in probability. The second law of thermodynamics states that in any closed system, entropy always increases, disorder always grows. But this isn't because there's a law forcing things to become disordered. It's because there are vastly more ways for things to be disordered than ordered. Imagine a room. There's one way to have all the air molecules perfectly stacked in the corner. There are countless trillions of ways for them to be spread throughout the room. So even though the laws of physics allow the molecules to spontaneously gather in the corner, the probability of that happening is so infinitesimally small that it might as well be impossible. This is entropy. It's not a force. It's a statistical inevitability. And it's the reason time appears to flow forward. Because the universe started in an incredibly low entropy state at the Big Bang, perfectly smooth and uniform, and has been evolving toward higher entropy ever since. Every moment that passes, the universe becomes slightly more disordered, and our brains, which form memories by creating ordered structures from disordered ones, naturally perceive this increase in entropy as the passage of time. But here's where it gets disturbing. If entropy is just statistics, then time isn't flowing. Nothing is actually moving from past to future. Instead, we're living in a static four-dimensional block of space-time where every moment that ever was or ever will be exists simultaneously. What we call the passage of time is just our consciousness moving through this block, experiencing one slice after another, like a film projector moving through frames. This is called the block universe, or eternalism. It suggests that your birth, your death, and every moment in between all exist right now, frozen in the structure of space-time. You're not moving through time, you're just becoming aware of different slices of your own four-dimensional self. Evidence for this comes from Einstein's relativity. In 1905, he proved that simultaneity is relative. Two events that happen at the same time for one observer might happen at different times for another observer moving at a different speed. This means there is no universal now, no moment that exists for everyone everywhere. Instead, now is just a label we apply to the slice of space-time we happen to be experiencing. NASA physicist Brian Greene describes it like this: past, present, and future are all equally real. They're just different locations in space-time. It's as if the universe is a loaf of bread, and time is just the direction you're slicing it. But if past and future both exist, then why can't we visit them? Why is time travel, at least to the past, seemingly impossible? The answer might surprise you, because according to general relativity, time travel is possible, not easy, not practical, but theoretically allowed by the laws of physics. When clocks disagree. Before we talk about travelling through time, we need to understand how time can be different for different people. This is time dilation, one of the strangest predictions of Einstein's theory of relativity, and one of the most thoroughly proven facts in all of science. In 1971, physicists Joseph Huffel and Richard Keating conducted an experiment so simple it sounds like a joke. They put atomic clocks on commercial airplanes, flew them around the world, and then compared them to atomic clocks that had stayed on the ground. The result? The clocks that had flown disagreed with the clocks that had stayed home. Not by much, just a few hundred nanoseconds. But the difference was real, measurable, and exactly what Einstein's equations predicted. Time, it turns out, runs slower when you're moving fast. At everyday speeds, the effect is negligible. But as you approach the speed of light, time dilation becomes dramatic. If you could board a spacecraft travelling at 99% the speed of light and journey to a star 50 light-years away, the trip would take you about 50 years as measured by people on Earth. But for you inside the ship, the journey would take only about 7 years. You would arrive 43 years younger than the people who stayed behind. This isn't a trick or a paradox, it's how the universe actually works. Time is not universal, it's local, personal, dependent on your motion and your position in a gravitational field. Gravity also dilates time. The stronger the gravitational field, the slower time runs. This effect is called gravitational time dilation, and it's been measured with incredible precision. Atomic clocks placed at different altitudes on Earth tick at different rates. A clock on a mountaintop runs slightly faster than a clock at sea level because it's farther from Earth's gravitational centre. The most extreme example occurs near black holes. At the event horizon of a black hole, gravity is so strong that time effectively stops from the perspective of a distant observer. If you watch someone fall into a black hole, you would see them slow down as they approach the horizon, their movements becoming more and more sluggish until they appeared to freeze completely, hovering just above the surface forever. But from the falling person's perspective, nothing unusual would happen. They would cross the horizon in a finite amount of their own time. It's only to the outside universe that they appear frozen. This creates a bizarre situation. From your perspective, the person has never crossed the horizon. From their perspective, they crossed it long ago. Both perspectives are equally valid. Time is literally different depending on where you are and how you're moving. GPS satellites rely on this effect. Because they orbit Earth at high speed and far from the surface, two different relativistic effects compete. Special relativity says their clock should run slower because they're moving fast. General relativity says their clock should run faster because they're farther from Earth's gravity. The general relativistic effect wins, meaning satellite clocks run about 38 microseconds faster per day than clocks on the ground. Without constantly correcting for this time dilation, GPS navigation would accumulate errors of several miles per day. So every time you use your phone to navigate, you're relying on the fact that time is not universal. But time dilation opens a door that leads to one of the most tantalizing possibilities in physics: time travel. The twin who stayed young. The twin paradox is one of the most famous thought experiments in relativity, and it demonstrates just how radical time dilation can be. Imagine two twins, Alice and Bob. Alice stays on Earth while Bob boards a spacecraft and travels to a nearby star at 90% the speed of light. The star is 10 light years away, so the round trip takes about 22 years as measured by Alice and everyone else on Earth. But when Bob returns, he's only aged about 10 years. He's now 12 years younger than his twin sister. This isn't science fiction. This is what relativity predicts, and it's been confirmed in countless experiments with particles, atomic clocks, and satellites. So why is it called a paradox? Because at first glance it seems symmetrical. From Bob's perspective, Alice is the one moving, so shouldn't she be younger? The resolution is that the situation isn't symmetrical. Bob had to accelerate and decelerate to make the trip. He changed reference frames. Alice never did. That acceleration breaks the symmetry and makes Bob's clock run slower. This means Bob has effectively travelled into Earth's future. He left in 2025, but when he returns it's 2047. He skipped 22 years of Earth's history in what felt like 10 years to him. This is real time travel, to the future, and it's not just possible, it's unavoidable if you move fast enough or fall deep enough into a gravitational field. Near a black hole, this effect becomes extreme. In 2014, the film Interstellar depicted astronauts landing on a planet orbiting close to a massive black hole. Due to extreme gravitational time dilation, 1 hour on the planet's surface equaled 7 years on Earth. When the astronauts returned to their ship, their colleague who had stayed behind had aged 23 years. This isn't fantasy. Physicist Kip Thorne, who served as scientific consultant for the film, confirmed that the math is accurate. NASA's Chandra X-ray Observatory and the Event Horizon Telescope have observed matter orbiting close to black holes, and the light we detect is time-dilated, redshifted by the warping of space-time itself. So if time travel to the future is possible, even if impractical, what about travelling to the past? The door that shouldn't open. Travelling backward in time is far more problematic. It's not just difficult or expensive. It might violate the fundamental structure of causality itself. Consider the grandfather paradox. You travel back in time and prevent your grandfather from meeting your grandmother. You're never born. But if you're never born, you can't travel back in time to prevent your own birth. The timeline collapses into contradiction. For decades, physicists assumed this meant backward time travel was simply impossible. The universe must have some mechanism, some cosmic censorship that prevents paradoxes from occurring. But then in 1949, mathematician Kurt Gödel found something shocking hidden in Einstein's equations. He discovered a solution to general relativity that describes a rotating universe, and in that universe, closed time-like curves exist. These are paths through space-time that loop back on themselves, allowing an object to return to its own past. Gödel's solution requires the entire universe to be rotating, which it doesn't appear to be. But it opened a door. If one solution to Einstein's equations allows time travel, might there be others? Turns out there are. In 1974, physicist Frank Tipler proposed that a rapidly rotating cylinder of infinite length could create closed time-like curves around it. In 1988, Kip Thorne and his colleagues showed that wormholes, hypothetical tunnels connecting distant regions of space-time, could potentially be used for time travel if one mouth of the wormhole were accelerated to near light speed. In 1991, physicist J. Richard Gott proposed that two cosmic strings, hypothetical one-dimensional defects in space-time moving past each other at high speed, could create closed time-like curves. None of these solutions are practical. Some require exotic matter with negative energy. Some require structures that probably don't exist in nature, but they all share one thing in common. They're mathematically consistent solutions to Einstein's equations, which means general relativity, our best theory of gravity and space-time, does not forbid time travel to the past. But what about the paradoxes? Some physicists argue that quantum mechanics might resolve them. In the many-worlds interpretation, every quantum event causes the universe to split into multiple parallel timelines. If you travel back in time and prevent your grandfather from meeting your grandmother, you don't erase your own timeline. You just create a new one where you were never born. Your original timeline remains intact. Another possibility is the Novikov self-consistency principle, proposed by physicist Igor Novikov in the 1980s. It states that the universe arranges itself in such a way that time travel paradoxes are automatically prevented. If you try to kill your grandfather, something will always go wrong. The gun will jam, you'll change your mind, something will intervene. Not because of fate or destiny, but because the laws of physics simply don't allow paradoxes to occur. In 2014, University of Queensland physicist Tim Ralph and his team ran a simulation of quantum particles travelling through time and found that the universe does seem to have a built-in mechanism to prevent paradoxes. The particles adjusted their behaviour in such a way that contradictions never arose. But here's the truly disturbing part. If closed time-like curves exist, even in principle, then the distinction between past and future breaks down completely. In a universe with time loops, an effect can precede its cause, information can flow backward through time, and the arrow of time, that fundamental one-way street we've been discussing, becomes meaningless. Quantum time, when past and future blur. If general relativity bends and stretches time, quantum mechanics does something even stranger. It makes time uncertain. In the quantum realm, particles don't follow definite paths through time. They exist in superpositions, occupying multiple states simultaneously until observed. And some experiments suggest that the future can reach backward to influence the past. This isn't philosophy, it's measurable physics. In 1978, physicist John Wheeler proposed a thought experiment called the delayed choice experiment. The setup is simple. You send a photon through a double-slit apparatus. If you observe which slit it passes through, it behaves like a particle, taking one definite path. If you don't observe it, it behaves like a wave, passing through both slits at once and creating an interference pattern. But here's Wheeler's twist. What if you wait until after the photon has passed through the slits to decide whether to observe it? Logically, the photon should have already chosen whether to behave as a wave or a particle, but quantum mechanics predicts otherwise. It predicts that your future measurement will retroactively determine the photon's past behaviour. In 2007, physicists at the Institut d'Optique in France actually performed this experiment using single photons. The results confirmed Wheeler's prediction. The choice made after the photon passed through the slits determined how it had behaved at the slits. The future influenced the past. This effect, confirmed in dozens of experiments since, suggests that time at the quantum level doesn't work the way we think. Cause and effect become murky. The arrow of time starts to point in both directions at once. Quantum entanglement makes this even stranger. When two particles become entangled, measuring one instantly affects the other, no matter how far apart they are. Einstein called this spooky action at a distance, and believed it proved quantum mechanics was incomplete. But experiments have confirmed entanglement thousands of times. It's real. In 2015, researchers at Delft University of Technology closed the final loopholes and proved that entanglement really does involve instantaneous correlations across space. Measure one particle, and its entangled partner reacts immediately, even if it's on the other side of the galaxy. This seems to violate relativity, which says nothing can travel faster than light. But here's the catch: no information actually travels. You can't use entanglement to send a message faster than light. The correlations only become visible after you compare measurements, which requires classical communication at light speed or slower. Still, entanglement hints at something profound about time and space. Some physicists, including Juan Maldacena and Leonard Susskind, have proposed that entanglement might actually be what creates space-time. In their view, the geometry of the universe emerges from quantum connections. Space and time aren't fundamental, they're emergent properties of quantum entanglement. If true, this would mean time doesn't exist at the deepest level of reality. It only appears when you zoom out and look at large collections of entangled particles. At the quantum scale, there is no time, only correlations, probabilities, and superpositions. This idea finds support in loop quantum gravity and string theory, two leading candidates for a theory of quantum gravity. Both suggest that space and time are quantized, divided into discrete chunks at the Planck scale, about 10⁻35 meters and 10⁻43 seconds. Below that scale, the concepts of space and time break down completely. Carlo Rovelli, one of the founders of loop quantum gravity, describes it like this: time does not exist at the fundamental level. It emerges from quantum interactions like temperature emerges from the motion of molecules. In this view, the flow of time is an illusion created by our macroscopic perspective. We see time because we're big, warm, complex systems made of countless particles. But at the quantum level, there is no past or future, only a timeless web of correlations. Recent experiments with quantum computers have begun exploring this idea. In 2019, physicists at Google simulated a quantum system where information appeared to travel backward in time. They created a state, let it evolve, then reversed the evolution using a complex sequence of quantum gates. For a brief moment, the system's entropy decreased, violating the arrow of time. The reversal only worked for a few quantum bits over a fraction of a second, before decoherence caused the system to collapse back into normal forward-moving time. But it demonstrated something remarkable. At the quantum level, time is reversible. The arrow of time only emerges when you scale up to systems with many particles, where probability and entropy take over. This connects back to the second law of thermodynamics. Entropy increases not because of a fundamental law, but because high entropy states are vastly more probable than low entropy ones. And our perception of time, our sense that the past is fixed while the future is open, emerges from that statistical asymmetry. But here's the unsettling implication. If time is just an emergent property, not a fundamental one, then the question, what is time, might not have an answer. Time might not be a thing at all. It might just be the label we give to the change we observe in a fundamentally timeless universe. The illusion of now, right now, you're reading these words. Now feels like the most real thing in your existence. The present moment seems vividly, undeniably real in a way the past and future are not. Your memories of yesterday feel distant, dreamlike. Your anticipation of tomorrow is abstract, uncertain. But this moment, this now, is concrete, except it's not. According to relativity, there is no universal now, no moment that exists for everyone everywhere. What you experience as now is just a slice of four-dimensional space-time, and that slice is different depending on how fast you're moving and where you are in a gravitational field. Imagine two observers, Alice on Earth and Bob on a spacecraft travelling at high speed. They each have their own now, their own present moment. But these present moments don't align. Events that are simultaneous for Alice happen at different times for Bob, and neither perspective is more correct than the other. Both are equally valid slices of space-time. This relativity of simultaneity was one of Einstein's most radical insights. It means the universe doesn't have a universal clock ticking out a single present moment. Instead, every observer carries their own present moment, and these presents don't agree. The implications are staggering. If there's no universal now, then in what sense does the present exist? And if the present doesn't exist in any absolute way, then what are we experiencing when we feel the passage of time? Neuroscience offers a partial answer. Your brain doesn't experience the world in real time. It takes about 80 milliseconds for sensory information to be processed and reach conscious awareness. When you see something, you're actually seeing it as it was 80 milliseconds ago. Your consciousness is perpetually lagging behind reality, living in the past, but your brain hides this lag from you. It creates the illusion of a seamless present by stitching together sensory inputs that arrive at slightly different times and presenting them to consciousness as simultaneous. What you experience as now is actually a constructed narrative, a story your brain tells you about events that have already happened. Studies of patients with brain injuries have revealed just how constructed this present moment is. People with damage to certain areas of the temporal lobe report that their sense of time becomes distorted. Events that happen seconds apart feel simultaneous, or events that happen simultaneously feel separated by long intervals. The flow of time, it turns out, is generated by neural processes in the brain. Damage those processes, and time stops flowing normally. This doesn't mean time is just psychological. Physical processes still unfold in sequence. Causes still precede effects. Entropy still increases. But the felt experience of time, the sensation that you're moving through moments, appears to be something your brain constructs, not something inherent to the universe. The philosopher and cognitive scientist Daniel Dennett describes consciousness as a user interface for navigating reality. Just as your computer's desktop is a simplified representation of complex underlying code, your experience of time might be a simplified representation of complex physical processes. The universe doesn't divide itself into past, present, and future. Your brain does that for you. Some meditation practices exploit this insight. When you meditate deeply, focusing on breath or sensation, the narrative sense of time can dissolve. Past and future recede. The constructed present expands. Experienced meditators report entering states where time seems to stop, where hours pass like minutes, where the distinction between now and not now disappears. These subjective experiences don't contradict physics, they reveal it. They show that our everyday experience of time is not fundamental but constructed, a trick of consciousness that helps us navigate a four-dimensional universe our brains weren't evolved to comprehend directly. But if the present is an illusion and time is relative, does that mean free will is an illusion too? If past, present, and future all exist simultaneously in the block universe frozen in four-dimensional space-time, then isn't everything already determined? Aren't your choices just part of a predetermined pattern you're helplessly experiencing? The clockwork universe. The question of free will in a deterministic universe has haunted philosophers for centuries, but physics has made it more acute. If the universe is a four-dimensional block where all events exist simultaneously, then the future already exists. You haven't reached it yet in your subjective experience, but it's already there, laid out in space-time as fixed and unchangeable as the past. This is hard to accept. It feels like you're making choices right now. It feels like the future is open, uncertain, full of possibilities. But if the block universe is correct, that openness is an illusion. The future is as determined as the past. You're not choosing. You're just discovering choices that were always going to happen. Classical physics supported this view. Newton's laws are deterministic. If you know the position and velocity of every particle in the universe at one moment, you can in principle calculate their positions and velocities at any other moment, past or future. the universe becomes a vast clockwork, ticking along predictable paths. The French mathematician Pierre-Simon Laplace took this idea to its logical conclusion in 1814. He imagined a hypothetical intellect that knew the precise location and momentum of every atom in the universe. This Laplace's demon, as it came to be called, could use Newton's laws to calculate the entire past and future of the cosmos. As Laplace wrote, "Nothing would be uncertain to it, and the future, just like the past, would be present before its eyes." In such a universe, free will is impossible. Every decision you make is the inevitable result of prior causes stretching back to the Big Bang. You feel like you're choosing, but you're just a biological machine executing a program written by the initial conditions of the universe. Quantum mechanics seem to offer an escape. Unlike classical physics, quantum mechanics is probabilistic. You can't predict exactly when a radioactive atom will decay, only the probability that it will decay within a given time. The outcome is genuinely random, not just unpredictable due to incomplete knowledge. This randomness might save free will, some philosophers argued. If the universe is fundamentally probabilistic, then the future isn't determined, it's open. Your choices might genuinely create new possibilities, rather than simply revealing predetermined ones. But here's the problem. Randomness isn't the same as freedom. If your decisions are determined by random quantum events in your neurons, you're not freely choosing. You're just rolling dice at the microscopic level. Your choices are unpredictable, but they're not free, they're arbitrary. Some physicists and philosophers have tried to find a middle ground. They argue that consciousness might have the ability to influence quantum events, collapsing wave functions in a way that's not purely random but also not determined. This would give you causal power over your actions without requiring that your choices be predetermined. But there's no evidence for this idea. Every experiment ever conducted shows that quantum measurements follow probabilistic rules with no room for conscious influence. If consciousness could collapse wave functions in a non-random way, we'd see violations of quantum mechanics. We don't. The block universe view makes the situation even more stark. If past, present, and future all exist simultaneously, then your entire life is already complete in space-time. The you of tomorrow already exists, experiencing events you haven't reached yet. Your subjective journey through time is just you becoming aware of different slices of your own four-dimensional self, like reading a book that's already been written. In this view, the question isn't whether the future is determined, it's whether the concept of determination even makes sense. If time is just a dimension like space, then asking whether the future is determined is like asking whether Denver is determined by New York. They're just different locations in a unified structure. Neither causes the other, they both just are. Physicist Brian Greene puts it this way: the unfolding of the future is not really unfolding at all. It's already there, waiting for you to experience it. But don't despair. Even in a block universe, your choices still matter. They're still part of the causal structure of space-time. The you of tomorrow exists because the you of today makes certain choices. Those choices are part of what creates your world line, your path through four-dimensional space-time. They're not free in some libertarian sense, but they're still yours, still part of who you are. And from your subjective perspective, moving through time moment by moment, the future is genuinely unknown. You can't see it. You can't access it. So even if it exists somewhere in the block universe, it remains open to you, a space of possibility and uncertainty. The lived experience of freedom, of choosing and acting and shaping your life, remains real, even if the ultimate structure of reality is more constrained than it appears. But here's something that will keep you awake tonight. There's a version of you somewhere in the block universe making different choices. A you who turned left instead of right. A you who said yes instead of no. And according to some interpretations of quantum mechanics, all those versions are equally real, existing in parallel timelines, branching and diverging with every quantum decision. In the many worlds interpretation, every time a quantum measurement occurs, the universe splits. One branch where the particle is spin up, another where it's spin down. One branch where you chose coffee, another where you chose tea. These branches don't interact, they can't communicate. But they're all equally real, all equally part of the quantum wave function. If many worlds is correct, then you're not just living one life. You're living countless versions of your life simultaneously, scattered across an infinite tree of branching possibilities. Every decision point creates new yous, each experiencing different outcomes, each convinced they're the only one. The block universe says your future already exists. Many worlds says all possible futures already exist. Between these two views, free will has nowhere to hide. And yet, something still bothers physicists about all this. Because while time might be a dimension of space-time, it's not quite like the spatial dimensions. You can move freely in space, backward and forward, left and right. But time only goes one way. Why? This brings us back to entropy, to the arrow of time, to the mystery of why the universe had such incredibly low entropy at the Big Bang. Because if time is just another dimension, there's no reason it should have a direction at all. No reason the future should be any different from the past. Unless the Big Bang's impossible beginning. The universe began in a state of extraordinarily low entropy. This is one of the most perplexing facts in all of cosmology. When the Big Bang occurred 13.8 billion years ago, matter and energy were distributed almost perfectly uniformly. The cosmic microwave background, the afterglow of the Big Bang, shows temperature variations of only about 1 part in 100,000. This uniformity represents incredibly low entropy, because entropy measures disorder and a smooth, uniform distribution is highly ordered. It's like having all the air molecules in a room perfectly evenly spaced, or all the cards in a deck sorted by suit and rank. It's a state that requires incredibly specific conditions. There are countless trillions of ways the universe could have started with high entropy, but only a tiny fraction of possibilities would produce the low entropy beginning we observe. Why did the universe start that way? Nobody knows. Physicist Sean Carroll has called this the most important unsolved problem in cosmology. The second law of thermodynamics says entropy always increases. But that raises a question. What made entropy so low to begin with? What set up the conditions for the arrow of time? Some cosmologists appeal to inflation, a period of exponential expansion that occurred in the first 10 or 32 seconds after the Big Bang. Inflation explains why the universe is so uniform, smoothing out any initial irregularities. But it doesn't explain why the pre-inflation universe had the specific properties needed to trigger inflation in the first place. It just pushes the mystery back one step. Others suggest that the low entropy beginning is just a statistical fluke. In an infinite multiverse where universes are constantly being created, most will start with high entropy. But a tiny fraction will by chance start with low entropy. We exist in one of those rare universes because only low entropy universes can support complex structures like stars, planets, and life. This is an anthropic explanation. We observe a low entropy beginning because we couldn't exist in a high entropy universe. But this feels unsatisfying. It doesn't explain why our particular universe has the initial conditions it does. It just says that somewhere in the multiverse, a universe with these conditions must exist. Roger Penrose proposed a more radical idea. He suggests that the low entropy at the Big Bang wasn't an accident or a statistical fluke. It was imposed by the structure of space-time itself. In Penrose's conformal cyclic cosmology, CCC, the universe goes through infinite cycles of expansion, heat death, and rebirth. At the end of each cycle, when the universe has expanded to infinite size and all matter has decayed into radiation, space-time becomes conformal, meaning it loses its sense of scale. In this state, Penrose argues, the end of one universe becomes the Big Bang of the next, and the low entropy of the new Big Bang emerges naturally from the high entropy end of the previous cycle. This is speculative, but Penrose claims to have found evidence for it in the cosmic microwave background. He identifies what he calls Hawking points, circular patterns in the CMB that he interprets as the evaporation signatures of supermassive black holes from the previous cosmic cycle. Most cosmologists remain skeptical, but the idea is tantalizing. If Penrose is right, time isn't linear. It's cyclic, repeating in endless loops, each Big Bang emerging from the ashes of a previous universe. Another possibility is that our universe isn't special at all. Perhaps most universes start with low entropy simply because that's a natural state for space-time. Physicist Lee Smolin has proposed a theory called cosmological natural selection in which universes reproduce through black holes. Every black hole, he suggests, creates a new universe on the other side of its singularity, with slightly different physical constants. Over countless generations, this process would naturally select for universes with properties that maximize black hole formation, including low initial entropy. But all these ideas remain speculative. The truth is, we don't know why the universe started with low entropy. We don't know why time has an arrow. We don't even know if the Big Bang was truly a beginning or just a transition from some earlier state. What we do know is that the low entropy Big Bang set everything in motion. It created the conditions for stars to form, for planets to coalesce, for life to emerge. Every memory you form, every choice you make, every moment you experience exists because the universe started in an improbable state 13.8 billion years ago. The arrow of time, the flow from past to future, is ultimately just the universe slowly forgetting its improbable beginning. Entropy increases, disorder grows, and the memory of that initial order fades. But the fact that it happened at all, that the universe began in such a specific state, remains one of the deepest mysteries in physics. And it raises an even deeper question. If time began at the Big Bang, what does "before the Big Bang" even mean? Before time existed, the phrase "before the Big Bang" might be meaningless. If time itself began at the Big Bang, then asking what came before is like asking what's north of the North Pole. The question assumes a direction that doesn't exist. Stephen Hawking made this point famously in his book A Brief History of Time. He argued that time has a boundary at the Big Bang but no edge. Just as the surface of a sphere is finite but has no boundary, time might be finite in the past but have no moment before which you can point. But not all cosmologists agree. Some models suggest time didn't begin at the Big Bang. They propose that our universe emerged from a pre-existing state, perhaps a previous contracting universe, or a quantum vacuum, or a higher dimensional bulk space in string theory. In loop quantum cosmology, a branch of loop quantum gravity, the Big Bang wasn't a singular beginning but a bounce. The universe was contracting from a previous phase, but quantum effects prevented it from collapsing all the way to a singularity. Instead, it reached a minimum size and then rebounded, creating what we call the Big Bang. In this model, time extends infinitely into the past. Our universe is just the latest in an endless series of expansions and contractions. String theory offers other possibilities. In the ekpyrotic model, our universe began when two higher dimensional brains collided in an extra dimension. The collision released energy, creating the hot, dense state we call the Big Bang. But the brains existed before the collision, meaning time might extend beyond our universe's apparent beginning. These ideas are speculative, but they're based on serious physics. They suggest that the Big Bang might not be the absolute beginning of everything, just the beginning of our observable universe. If time existed before the Big Bang, then what was it like? Without matter or energy, without space as we know it, what could time even mean? Some physicists suggest that in the quantum realm before the Big Bang, time itself was quantum. It didn't flow smoothly but flickered in and out of existence, a probabilistic foam, where the concepts of before and after became meaningless. In this timeless quantum state, the Big Bang wasn't an event that happened at a specific time. It was the moment when time crystallized out of the quantum foam and became a classical dimension. This idea connects to Carlo Rovelli's notion of thermal time. Rovelli argues that time, as we experience it, emerges from the thermodynamic properties of matter. In a universe without matter, without temperature gradients, without entropy, there would be no time in any meaningful sense. Time is not fundamental. It's a consequence of the second law of thermodynamics. But if that's true, then before the Big Bang, in whatever quantum state preceded our universe, there might have been no time at all, just a timeless realm of possibilities, a superposition of all potential universes. Our universe emerged when one of those possibilities actualized, when the wave function of the cosmos collapsed and time began. This raises a final, vertiginous possibility. If time is emergent, if it crystallizes out of deeper structures, then it might not be unique. There might be other times, other temporal dimensions woven through the fabric of reality, inaccessible to us but as real as our own. In some versions of string theory, there are additional time dimensions. Our familiar time might just be one of several temporal directions, the only one we can perceive because of the way our universe is structured. These extra time dimensions would be compactified, curled up too small to observe directly, but their effects might show up in the laws of physics. If extra time dimensions exist, they would radically change our understanding of causality. Events could influence each other across different time streams. The arrow of time might point in multiple directions simultaneously. The past and future might not be arranged in a simple line, but form a complex branching structure where multiple timelines intersect and diverge. These ideas push the limits of what we can currently test, but they remind us that our understanding of time remains profoundly incomplete. We know how to measure it, how to manipulate it with relativity, how it behaves in quantum systems, but we still don't know what it is, where it came from, or why it has the properties it does. And that brings us to the most unsettling possibility of all. What if time isn't real? Not in the sense that it's an illusion, but in the sense that it's not a fundamental feature of reality. What if time is like temperature, an emergent property that only makes sense for large collections of particles? At the deepest level, in the quantum realm where reality is just wave functions and probabilities, there might be no time at all. This is the direction cutting-edge physics is heading. Theories of quantum gravity, which attempt to merge general relativity with quantum mechanics, increasingly suggest that space-time itself is emergent. It's not fundamental. It arises from something deeper, something more abstract. In loop quantum gravity, space-time is woven from tiny loops of quantum geometry, each about a Planck length in size, 1035 meters. These loops don't exist in space and time. They are space and time, and at scales smaller than the Planck length, the concepts of distance and duration simply don't apply. In string theory, space-time emerges from the vibrations of one-dimensional strings and the geometry of extra dimensions. But the strings themselves don't exist in space-time. They're more fundamental than space-time, and in some approaches to quantum gravity, like causal set theory and Wheeler-DeWitt equation approaches, time disappears entirely from the fundamental equations. There's no time variable at the deepest level, just a timeless quantum state from which our experience of time somehow emerges. If this is correct, then every question we've been asking, what is time? Why does it flow forward? Can we travel backward? Is based on a false premise. Time isn't a thing that flows or has a direction. It's a pattern, an appearance, an emergent structure that only exists at the macroscopic scales where entropy increases and memories form. This is deeply disorienting. It suggests that the most fundamental aspect of your existence, your experience of moving through time from past to future, is not reflecting something real about the universe. It's a feature of your consciousness, a way your brain organizes experience, but not a feature of ultimate reality. And yet, even if time is emergent, it's still real at our level. Just as temperature is real even though it emerges from molecular motion, time is real even if it emerges from quantum correlations or entropy gradients. You still age. Clocks still tick. The universe still evolves from low entropy to high entropy. The deep question is, why does reality have this layered structure? Why does timeless quantum realm give rise to a universe where time appears to flow? Nobody knows, but understanding this question might be the key to understanding not just time, but reality itself. The universe's memory problem. Here's something physicists don't talk about enough. The universe appears to have perfect memory of the past, but no knowledge whatsoever of the future. Every physical law we know is time reversible at the microscopic level. Newton's laws, Maxwell's equations, even Einstein's general relativity all work equally well forward or backward in time, and yet macroscopically the universe only remembers one direction. You remember yesterday, you don't remember tomorrow. A broken egg doesn't spontaneously reassemble. A burned book doesn't unburn itself. The past leaves traces, footprints in space-time. The future leaves nothing. This asymmetry is encoded in the structure of causality itself. In physics, we can always find the cause of an effect by looking to the past. But we cannot find effects by looking to the future because the future hasn't happened yet, at least not in any accessible way. But here's the puzzle. If the laws of physics are time-symmetric, why is causality asymmetric? Why do causes precede effects rather than following them? The standard answer is entropy. In a low-entropy past, information is concentrated and ordered. As entropy increases, information spreads out, becoming diffuse and disordered. This spreading creates records, memories, traces of the past. But there's no corresponding process creating traces of the future, because the future is higher entropy, meaning information about it has dissipated before it can form coherent records. Think of it this way. When you remember something, your brain contains physical traces of past events, patterns of neural connections shaped by experience. These traces exist because entropy was lower when the memory formed. The information could be captured and preserved in a relatively ordered state. But you can't have memories of the future because the future is higher entropy. Any information about it is already too dispersed to form coherent patterns in your brain. The second law of thermodynamics guarantees that information flows from ordered states to disordered ones, from low entropy to high entropy, from past to future, never the reverse, or almost never. Because in certain exotic conditions, information can appear to flow backward through time, not in violation of physics, but as a consequence of quantum mechanics. In 2012, physicists at the University of Rochester demonstrated quantum retrocausality in a carefully controlled experiment. They showed that measurements made on entangled particles could correlate with earlier measurements in ways that seemed to require information to flow backward through time. The experiment didn't violate causality in the usual sense. No signals travelled faster than light, and no paradoxes occurred. But it demonstrated that quantum correlations don't respect the normal arrow of time the way classical correlations do. Some interpretations of quantum mechanics, particularly the transactional interpretation proposed by John Cramer, explicitly involve waves travelling backward in time. In this view, when a quantum measurement occurs, a retarded wave travels forward in time from the source, and an advanced wave travels backward in time from the detector. The two waves meet in the middle, creating what we observe as a quantum event. This sounds bizarre, but it makes the same predictions as standard quantum mechanics, and it resolves some of the philosophical puzzles surrounding wave function collapse. If the future detector sends a signal backward in time, then the particle knows where it's supposed to end up, resolving the mystery of how it seems to choose a particular outcome. But if information can flow backward through time at the quantum level, why doesn't this propagate to the macroscopic world? Why don't we see eggs unbreaking or coffee spontaneously getting hotter? The answer is decoherence. When a quantum system interacts with its environment, the delicate quantum superpositions that allow backward in time information flow collapse into classical states. This decoherence happens almost instantaneously for large objects, which is why macroscopic systems obey the arrow of time even if microscopic ones don't. Decoherence is also why Schrödinger's cat, the famous thought experiment where a cat is simultaneously alive and dead, never actually occurs in practice. The cat is too big, too warm, too entangled with its environment. The quantum superposition collapses long before any human observer opens the box. The cat's fate is sealed not by conscious observation, but by thermodynamics. This connects back to time's arrow. Quantum mechanics might be time-symmetric at its core, but decoherence, which arises from entropy increase, introduces an asymmetry. The future decoheres into classical states. The past is already decohered, and this asymmetry is what gives time its direction. But here's the truly strange part. Decoherence doesn't just happen in our universe. It happens in the multiverse too, if many worlds is correct. Every time a quantum measurement occurs, the universe branches, but these branches immediately begin decohering from each other, becoming mutually inaccessible. The past is a single branch. The future is countless branches spreading like a tree, and we're riding along one particular branch, unable to access the others. In this view, the arrow of time isn't about entropy alone, it's about the branching structure of reality itself. The future is open because it's multiple. The past is fixed because it's singular. Time flows not because something is moving, but because reality is constantly bifurcating. This is one of the most profound insights of modern physics. The arrow of time, the directionality we experience so fundamentally, might not be a property of time itself. It might be a property of the branching structure of the quantum multiverse. When space becomes time. Near the event horizon of a black hole, something extraordinary happens. The roles of space and time swap. Inside the horizon, time becomes spatial and space becomes temporal. This isn't a metaphor, it's a mathematical consequence of general relativity. Outside a black hole, you can stay still in space while time carries you forward. You have a choice about where to go in space, but not about moving forward in time. But inside the horizon, this reverses. You have no choice about moving inward toward the singularity, but you could in principle move backward and forward in time. Of course, you can't actually do this. Once inside the horizon, all paths lead to the singularity within a finite amount of proper time, usually measured in fractions of a second for stellar mass black holes. But the mathematical structure is clear. Inside the event horizon, the singularity isn't a place in space, it's a moment in time, an inevitable future you cannot avoid. This time-space swap has profound implications. It suggests that time and space are more intimately connected than we normally think. They're not fundamentally different types of dimensions, they're just different aspects of space-time, and under extreme conditions they can trade roles. Physicist Kip Thorne describes it this way: outside the horizon, the singularity is hidden in your future. Inside the horizon, it becomes your inevitable destination, located not somewhere in space, but somewhere in your future. This connects to the holographic principle, one of the most revolutionary ideas in modern physics. The holographic principle states that all the information contained in a volume of space can be encoded on the boundary of that volume, like a hologram. This principle emerged from studying black holes and has profound implications for how we understand reality. If the holographic principle is correct, then our three-dimensional universe might actually be a projection of information encoded on a two-dimensional boundary at the edge of space-time. In this view, what we experience as three-dimensional space with time flowing through it is actually a holographic image created by quantum information on a distant boundary. This sounds like science fiction, but it's supported by calculations in string theory and quantum gravity. One Maldaceno's ADAS-CFT correspondence discovered in 1997, provides a mathematical framework for this holographic duality. It shows that a quantum field theory in 3 spatial dimensions is mathematically equivalent to a gravitational theory in 4 spatial dimensions plus time. What does this mean for time? It suggests that time, like space, might be emergent from deeper quantum information theoretic structures. At the most fundamental level, reality might consist of quantum bits of information, and space-time emerges from the patterns and correlations among these bits. In this view, asking what time is becomes like asking what a computer image is. The image exists as a pattern of pixels, but it's not made of image substance. It's an emergent structure arising from the arrangement of information. Similarly, time might not be made of time substance. It might be an emergent structure arising from quantum correlations. Recent work on tensor networks and quantum error correction has strengthened this view. These mathematical structures, used to describe how quantum information organizes itself, naturally give rise to space-time geometries. Einstein's equations, which describe how space-time curves, emerge as conditions for optimal quantum error correction. This suggests that space-time, including time, is literally made of quantum information. And if that's true, then understanding time means understanding how information organizes, propagates, and processes itself in quantum systems. But if time emerges from quantum information, here's the nightmare scenario. What if that information could be corrupted? What if the quantum substrate that generates time could glitch, creating regions where time doesn't flow normally? Where past and future become tangled, where causality breaks down, where the arrow of time points in the wrong direction? This isn't idle speculation. Some cosmological models predict that in the very early universe, before inflation fully smoothed space-time, there might have been regions where time was chaotic, flowing in multiple directions at once or not flowing at all. These time bubbles would have been eliminated during inflation, but they hint at something unsettling. Time is only well behaved in well-ordered regions of space-time. In highly curved or quantum-dominated regions, the rules might be different. Near singularities, at the centres of black holes, or in the quantum foam at the Planck scale, time might not have a consistent direction. Events might not have clear causal relationships. The distinction between past and future might blur into meaninglessness. We've already seen hints of this in quantum mechanics. The delayed choice experiment shows that future measurements can retroactively determine past states. Quantum erasers show that destroying information in the present can restore interference patterns that seem to have been destroyed in the past. These effects don't violate causality in the classical sense, but they reveal that quantum correlations don't respect the arrow of time the way classical correlations do. What happens if we scale this up? What if there are macroscopic regions of space-time where quantum effects dominate and time becomes chaotic? We might never encounter such regions in our observable universe, but they might exist somewhere in the vast cosmic landscape, hidden behind event horizons or in distant regions of the multiverse. And if they exist, they pose a fundamental question. Is our experience of time, with its clear past to future arrow and its reliable causality, just a local accident? Are we living in an unusually well-ordered corner of reality where time happens to flow smoothly, while elsewhere in the cosmos time is a tangled mess? This brings us to one of the deepest questions in physics. Not what is time, but why is time? Why does the universe have this feature at all? Why not a timeless realm where nothing changes, where all states exist simultaneously in perfect equilibrium? The answer might connect to one of the most profound principles in physics, symmetry breaking. Why time had to begin? The universe could have been static, eternal, unchanging, perfectly balanced, but it's not. Something broke the symmetry. Something created an arrow, a direction, a flow from past to future, and that breaking of symmetry is what made time possible. In the earliest moments after the Big Bang, the universe was symmetric in many ways. The 4 fundamental forces, gravity, electromagnetism, the strong nuclear force, and the weak nuclear force were unified into a single force. Matter and antimatter existed in equal amounts. The distribution of energy was perfectly smooth. But as the universe expanded and cooled, these symmetries broke. The forces separated. Matter slightly outnumbered antimatter. Tiny quantum fluctuations created ripples in the smoothness. These broken symmetries gave structure to the universe, allowing stars, galaxies, and eventually life to form. Time's arrow might be the result of the most fundamental symmetry breaking of all, the breaking of time reversal symmetry. In the earliest moments, the universe might have been time symmetric, meaning physical processes could run equally well forward or backward. But as the universe evolved, this symmetry broke, establishing a preferred direction for time. This breaking might be connected to CP violation, an asymmetry between matter and antimatter discovered in the 1960s. Certain particles decay differently depending on whether time is running forward or backward, a clear violation of time reversal symmetry. This violation is what allowed matter to outnumber antimatter in the early universe, giving us a universe made of stuff rather than just pure radiation. If CP violation can break time reversal symmetry for particles, might a similar process have broken time reversal symmetry for the universe as a whole? Might the Big Bang have been the moment when time chose a direction? Some cosmologists think so. They propose that the arrow of time is not a fundamental feature of the laws of physics, but an emergent feature that arose from the specific conditions of the Big Bang. In the very first moments, when the universe was quantum and chaotic, time might have had no preferred direction. But as the universe expanded and cooled, entering a phase where entropy could increase, time's arrow crystallized. This is speculative, but it's based on solid physics. It suggests that time, like space and matter, is not eternal. It had a beginning. And that beginning wasn't just the start of the universe. It was the start of change, of causality, of the distinction between past and future. Before the Big Bang, if that phrase even makes sense, there might have been no time. Not because time didn't exist, but because there was no change, no entropy increase, no arrow. Just a timeless quantum state where all possibilities existed simultaneously. And then, for reasons we don't understand, that symmetry broke. Change became possible. Entropy began increasing, and time, as we know it, began. The quantum origin of moments. Every moment you experience is a quantum event, not in some vague, mystical sense, but in a precise physical sense. Your brain processes information through quantum interactions and neurons, and each conscious moment corresponds to a cascade of quantum measurements, collapsing wave functions into definite states. This isn't pseudoscience, it's neuroscience informed by quantum mechanics. Roger Penrose and Stuart Hameroff have proposed that consciousness might arise from quantum processes in microtubules, structures inside neurons. While their specific theory remains controversial, the broader point is well established. Brains are physical systems obeying quantum mechanics, and consciousness is somehow connected to that quantum substrate. What does this mean for time? It means your experience of time, the feeling of moving from one moment to the next, might be fundamentally linked to quantum decoherence, the process by which quantum superpositions collapse into classical states. When decoherence occurs, a quantum system chooses a definite state from among many possibilities. This choice is irreversible and happens in a definite direction, from past to future. You can't undecohere a system any more than you can unbreak an egg. Decoherence creates the arrow of time at the quantum level. If consciousness arises from quantum processes, then each moment of conscious experience might correspond to a decoherence event. The feeling of time passing might literally be the experience of quantum wave functions collapsing, one after another, creating the discrete moments that form the stream of consciousness. This would explain why time feels like it flows. It's not that time itself flows, it's that conscious experience is built from discrete quantum events, each one creating a moment. And because these events are driven by entropy increase and decoherence, they naturally occur in a temporal sequence, from low entropy past to high entropy future. Some physicists go further. They suggest that consciousness might actually be necessary for time to exist. In the most radical interpretation of quantum mechanics, the Copenhagen interpretation, wave functions only collapse when observed. Without observers, the universe would remain in a timeless superposition of all possible states. It's only through observation, through consciousness, that reality crystallizes into definite moments arranged in temporal sequence. This is deeply controversial. Most physicists reject the idea that consciousness is required for wave function collapse. But the connection between consciousness, observation, and time remains a mystery. Why does it feel like time flows? Why do we experience moments sequentially rather than all at once? Why does consciousness seem to ride along the arrow of time rather than existing outside it? These questions blur the boundary between physics and philosophy, but they hint at something profound. Time might not be just a feature of the external universe. It might be intimately connected to how conscious beings like us process information, form memories, and navigate reality. In the block universe view, all moments exist simultaneously, but we only experience them one at a time, in sequence, because that's how consciousness works. Our brains can't process all of four-dimensional space-time at once. We have to sample it moment by moment, creating the illusion of time flowing. But perhaps it's not an illusion. Perhaps the flow of time is real, but only for conscious observers. Perhaps the universe is both a timeless block and a flowing stream, depending on your perspective. The objective structure is timeless. The subjective experience is temporal. This dual nature of time, both static and flowing, objective and subjective, might be the key to understanding it. Time isn't just one thing, it's a relationship between observer and observed, between consciousness and cosmos. The speed of now. Here's something strange. The present moment seems to have duration. You don't experience time as a series of instantaneous snapshots. Instead, you experience a specious present, a window of time about 2-3 seconds long that feels like now. Psychologists have known this for over a century. William James, in his 1890 Principles of Psychology, noted that we perceive time in chunks, not points. You hear a melody as a coherent sequence, not as isolated notes. You read a sentence as a meaningful unit, not as separate words. This specious present is created by your brain. It integrates sensory information arriving over a short time window and presents it to consciousness as a unified moment. What you experience as now is actually about 2 to 3 seconds of the recent past, stitched together into a seamless present. Recent neuroscience has shown that different parts of the brain have different specious presence. Visual processing operates on a timescale of about 80 milliseconds. Auditory processing is faster, about 10 milliseconds. Touch is even faster. Your brain has to constantly synchronize these different streams, creating a unified sense of now from information arriving at different times. This synchronization can break down. In certain neurological conditions, patients report that sensory experiences feel temporally disjointed. What they see and what they hear seem to happen at different times. The present moment fragments into disconnected pieces. This reveals something important. The present isn't a property of the universe, it's a construction of the brain. Different brains might construct different presents. An insect with much faster neural processing might experience a present that's only milliseconds long. An AI might not have a specious present at all, processing information without creating a unified now. The speed at which you experience time, the rate at which moments seem to pass, is not fixed by physics. It's determined by the speed of information processing in your brain. This is why time seems to slow down in emergencies. your brain processes more information per unit time, creating more detailed memories, making the experience feel longer in retrospect. It's also why time seems to speed up as you age. Childhood memories feel stretched out because you are encoding more novel information. Adult life, filled with routine and repetition, encodes less information per day, making time feel like it's flying by. You're not experiencing time differently. You're just forming fewer memories per unit time, creating the illusion that time is accelerating. This means the rate at which you experience time is flexible, dependent on brain function and information processing. And if we could modify those processes, we could potentially change how we experience time's passage. Some drugs already do this. Psilocybin, the psychedelic compound in magic mushrooms, alters time perception dramatically. Users report that minutes feel like hours, or conversely, that time loses meaning entirely. This happens because psilocybin disrupts the brain's normal temporal processing, breaking down the specious present and altering the sense of duration. Similarly, certain meditative states can dissolve time perception. Advanced meditators report experiences where past, present, and future seem to merge, where the flow of time stops, where consciousness expands beyond its normal temporal boundaries. These aren't hallucinations. They're what happens when the brain's temporal processing is deliberately altered through practice. This suggests that our normal experience of time, the steady flow from past to future at a consistent rate, is just one possible mode of temporal consciousness. Other modes are possible, modes where time flows differently or doesn't flow at all, where the distinction between moments blurs, where the arrow of time becomes negotiable. If we understood the neural mechanisms creating temporal experience, we might be able to engineer new ways of experiencing time. We might be able to slow down subjective time, making an hour feel like a day, or speed it up, making a long journey feel instantaneous, or even create experiences that don't unfold in temporal sequence at all, allowing you to experience multiple moments simultaneously. These possibilities are no longer science fiction. As neuroscience advances, as we map the brain's temporal processing systems in greater detail, as we develop technologies to interface directly with neural processes, the prospect of manipulating time experience becomes real. But there's a deeper question lurking here. If our experience of time is so flexible, so dependent on brain function, what does that say about time itself? Is the time we experience, the flow of moments, just an artifact of neural processing? Or is it revealing something true about the structure of reality? Perhaps both. Perhaps there are two kinds of time: physical time, the coordinating space-time that appears in physics equations, and experiential time, the felt sense of duration and flow created by consciousness. These two times are related but not identical. Physical time is objective and universal. Experiential time is subjective and variable. And this brings us to one of the most profound questions. Which time is more real? Here's what keeps physicists awake at night. We have two theories of time, and they contradict each other. General relativity says time is a dimension of space-time, flowing smoothly and continuously, warped by mass and energy but fundamentally geometric. Quantum mechanics says time is something else entirely, a parameter in equations, not a dimension at all, and at the smallest scales it might not exist. These two theories have never been successfully unified. They make different predictions about what happens in extreme conditions like the Big Bang or black hole singularities. And at the heart of this incompatibility is the nature of time itself. In relativity, time is background dependent. It's woven into the fabric of space-time. In quantum mechanics, time is background independent. It's external to the quantum state. This difference might seem technical, but it's fundamental. It means we don't actually know what time is at the deepest level of reality. The search for quantum gravity, a theory that would unify relativity and quantum mechanics, is fundamentally a search for the true nature of time. Will quantum gravity reveal that time is fundamentally geometric, as relativity suggests? Or will it show that time is emergent from quantum processes, as some interpretations of quantum mechanics imply? The answer might be neither. It might be something stranger, something we haven't imagined yet. Because every time we peer deeper into the nature of reality, we discover that our intuitions, our everyday experiences, are misleading. Space isn't absolute. Time isn't universal. Matter isn't solid. Reality isn't definite until observed. So why should time be what it seems? As we move into the next part of our journey, we're going to explore the most extreme manifestations of time in the universe. Places where time doesn't just bend but breaks, where clocks stop ticking, where past and future cease to have meaning, where the very concept of when becomes as meaningless as asking what colour is Tuesday. We're going to journey to the edge of black holes, where time slows to a crawl, to the birth and death of the universe, where time begins and ends, and to the strange borderlands of quantum mechanics, where time might not exist at all. Because if we want to understand what time is, we need to see what happens when time stops being itself, when it reaches its breaking point, when it reveals, finally, what it was hiding all along. Take a deep breath. The first act of this story has shown you that time is not what you thought. The second act will show you what happens when time stops pretending to be simple. The possibilities of time. The horizon. Where time stops, black holes are not holes. They're not empty voids in space. They're the opposite. Regions where matter has collapsed so completely that space curves back on itself and time comes to a halt. At the centre lies a singularity, a point where density becomes infinite and the laws of physics break down. But before you reach that singularity, you encounter something even stranger. The event horizon. The event horizon is not a physical surface. There's nothing there. No membrane or boundary you can touch. It's a mathematical line in space-time, the point of no return. Cross the horizon and no force in the universe can bring you back. Not because you're trapped inside something, but because all paths through space-time now point inward. The future direction, the only direction time allows you to move, leads inevitably to the singularity. From outside, watching someone fall toward a black hole, you'd never see them cross the horizon. As they approach, time dilation becomes extreme. Their clock slows relative to yours. They move more and more sluggishly. Light from them redshifts, dimming and stretching toward infrared. Eventually, they seem to freeze at the horizon, hovering there forever, asymptotically approaching, but never crossing. This isn't an optical illusion. From your reference frame, they genuinely never cross. The event takes an infinite amount of your time. The last photon they emit before crossing takes literally forever to reach you. In a very real sense, from the perspective of the external universe, nothing ever falls into a black hole. Everything accumulates at the horizon, frozen in time. But from the perspective of the falling person, something completely different happens. They cross the horizon in a finite amount of their own proper time. For a supermassive black hole like Sagittarius A, the one at the centre of our galaxy, the crossing would be smooth and unremarkable. No violent forces, no dramatic moment, just a quiet passage across an invisible line. Once inside, though, their fate is sealed. The singularity lies in their future, not their spatial ahead. They can no more avoid it than you can avoid next Tuesday. Every possible path through space-time, every action they could take leads to the singularity. It will happen in their future, typically within fractions of a second for stellar mass black holes, or hours for supermassive ones. At the singularity, tidal forces become infinite. You'd be stretched lengthwise and compressed sideways, a process astrophysicists grimly call spaghettification. Your atoms would be torn apart, your particles would be crushed to infinite density, and then? Nobody knows. General relativity predicts a singularity, a point where its own equations break down and produce nonsense. Infinite curvature, infinite density, division by zero in the math. This breakdown tells us that something is missing from our understanding. Quantum mechanics should become important at singularities, but we don't have a theory of quantum gravity to describe what actually happens. The singularity might not be a point at all. It might be a quantum foam, a region where space-time itself becomes granular and uncertain. Or it might be something stranger, a bridge to another universe, a point where time ends or begins again. In 2019, the Event Horizon Telescope captured the first image of a black hole shadow in galaxy M87. The glowing ring of light surrounding darkness confirmed everything relativity predicts about event horizons. That darkness isn't empty space, it's a region of space-time so warped that light cannot escape. And somewhere inside that darkness, time itself has become strange. Rotating black holes are even more exotic. They're called Kerr black holes after mathematician Roy Kerr, who solved Einstein's equations for a spinning black hole in 1963. A Kerr black hole has two horizons, an outer event horizon and an inner Cauchy horizon. Between them lies the ergosphere, a region where space-time itself is dragged around by the black hole's rotation. In the ergosphere, you cannot remain stationary. Even if you fire your rockets at maximum thrust, space-time itself is moving so fast that you're carried along like a leaf in a stream. This frame dragging is so extreme that standing still would require moving faster than light, which is impossible. And if you somehow manage to cross both horizons and survive the journey to the black hole's core, Kerr's mathematics predict something astonishing. Instead of a point singularity, you'd encounter a ring singularity, and passing through that ring might lead not to destruction but to another region of space-time, possibly another universe entirely. This is speculative. We have no observational evidence of what happens inside a black hole, but the mathematics of general relativity allow for these possibilities. The ring singularity could act as a gateway, a tunnel through space-time connecting distant regions or even different universes. These tunnels are called wormholes, tunnels through space-time. A wormhole, also called an Einstein-Rosen bridge, is a theoretical shortcut through space-time. Imagine space as a flat sheet of paper. 2 points on the paper might be far apart if you travel along the surface, but if you fold the paper so the 2 points touch, you could poke a hole through both layers and create a shortcut, a tunnel connecting them. In 1935, Einstein and physicist Nathan Rosen showed that general relativity allows such structures. Solve Einstein's field equations in a particular way, and you get a geometry with two mouths, two openings in space-time connected by a throat. Enter one mouth, travel through the throat, emerge from the other mouth. You've crossed vast distances without travelling through the space in between. The catch: Einstein-Rosen bridges are unstable. They collapse almost instantly, closing before anything can pass through. To keep a wormhole open, you'd need exotic matter, matter with negative energy density. Such matter would push instead of pull, creating negative gravity that holds the throat open against its natural tendency to collapse. Does exotic matter exist? In ordinary circumstances, no. All normal matter has positive energy density. But quantum field theory predicts that exotic matter is possible, at least temporarily. The Casimir effect, first measured in 1948, shows that quantum vacuum fluctuations can create small regions of negative energy density between closely spaced metal plates. In 1988, physicist Kip Thorne and his colleagues proposed that you could use such quantum effects to stabilize a wormhole. It would require enormous amounts of exotic matter, far more than we could create with current technology, but it's not forbidden by the laws of physics. It's just extremely impractical. But here's where it gets interesting. If you could create and stabilize a wormhole, you could use it for faster-than-light travel. Not by moving faster than light through space, but by travelling through space-time along a shortcut where the distance itself is less. And once you have faster-than-light travel, even of this indirect kind, you potentially have time travel. Here's how it works. Imagine you create a wormhole with two mouths, A and B. sitting side by side on Earth. Now you take mouth B and accelerate it to near light speed on a long journey, then bring it back. Because of time dilation, less time passes for mouth B than for mouth A. When you return, mouth A and mouth B are still connected through the wormhole throat, but mouth B is now younger than mouth A. There's a time difference between the two ends. If you enter mouth A, which is in the year 2050, you might emerge from mouth B in the year 2030, travelling 20 years into the past. This is the Thorne-Morris traversable wormhole time machine, proposed in 1988. It doesn't violate relativity because you're not moving faster than light through space. You're using a combination of time dilation and spatial shortcuts to arrive at an earlier time. The laws of physics seem to allow it, but there's a problem: causality. If you travel back to 2030 through the wormhole, you could change events that would prevent your 2050 self from creating the wormhole in the first place. The grandfather paradox again. Thorne and his colleagues investigated whether the laws of physics would prevent such paradoxes. They found something remarkable. When you try to create a closed time-like curve, a path through space-time that loops back to its own past, quantum effects intervene. Vacuum fluctuations in the wormhole throat build up, creating enormous energy densities that threaten to destroy the wormhole before any paradox can occur. This is called the chronology protection conjecture, proposed by Stephen Hawking in 1992. Hawking argued that the laws of physics conspire to prevent time travel to the past, not because of some fundamental principle, but because quantum effects automatically destabilize any structure that would allow closed time-like curves. As Hawking put it, the laws of physics do not allow time machines to appear, but the conjecture remains unproven. We don't have a complete theory of quantum gravity to tell us what really happens. Some calculations suggest chronology protection holds. Others suggest it might fail in certain conditions. The question remains open, and if wormholes do exist naturally in the universe, perhaps created in the violent conditions of the early Big Bang, they might provide shortcuts through space-time without requiring exotic matter. In 2019, physicists proposed that quantum entanglement itself might create tiny wormholes at the Planck scale, connecting entangled particles through microscopic bridges in space-time. If this EREPR conjecture, named after Einstein-Rosen bridges and Einstein-Podolsky-Rosen entanglement, is correct, then the universe is already riddled with wormholes. They're just far too small for anything macroscopic to pass through, but they might be enlargeable. With sufficient energy and the right quantum manipulations, these microscopic wormholes might be widened into traversable tunnels. This is highly speculative, but it shows that the question of time travel isn't settled. The laws of physics leave the door open just a crack, and that crack might be enough. Here's what's truly disturbing about wormholes. If they exist, if they can be traversed, then the universe has already created them. Somewhere out there, in the chaotic early moments after the Big Bang, quantum fluctuations might have spawned wormholes that connected different points in space-time, and some of those connections might link the distant past to the far future. If so, then information from the future might already be leaking into the past. Subtle influences, quantum correlations spanning billions of years, connecting events that seem unrelated. We wouldn't notice. The effects would be tiny, buried in quantum noise, but they'd be there. Quiet violations of causality woven into the fabric of space-time itself. And if future events can influence the past through primordial wormholes, then the past isn't fixed after all. It's constantly being shaped by the future, creating a self-consistent loop where cause and effect blur into a tangled web. The universe wouldn't be a film unrolling forward through time. It would be a negotiation, a conversation between past and future, each influencing the other until they settle into a stable configuration that allows both to exist. This is not how we normally think about time, but it might be how the universe actually works. Some cosmologists have taken this idea seriously. In 2006, physicists Yakir Aharonov and Jeff Tolleckson proposed that quantum mechanics is fundamentally time-symmetric. with influences flowing both forward and backward through time. They called this the two-state vector formalism, and experiments have confirmed some of its predictions. In this view, the present moment is determined by two wave functions, one propagating forward from the past, the other propagating backward from the future. What we observe is the interference pattern between these two waves. The past constrains what can happen, but so does the future. Causality runs in both directions. If true, this would revolutionize our understanding of time. The future wouldn't be open and undetermined. It would be just as real as the past, just as capable of influencing the present. Free will, in any traditional sense, would be impossible. Your choices tomorrow are already constraining your choices today, creating a self-consistent pattern where past and future lock together like pieces of a puzzle. This is deeply uncomfortable. It suggests that you're not actually making choices in the way you think. You're discovering choices that have already been negotiated between your past and future selves, choices that form a coherent pattern across your entire four-dimensional world line. But perhaps comfort isn't the point. Perhaps the universe isn't obligated to make sense in ways that align with our intuitions. Perhaps time is stranger than we ever imagined, and we're only now beginning to glimpse its true nature. The cosmic speed limit light travels at 299,458 meters per second in a vacuum. This number isn't just a measured velocity, it's a fundamental constant woven into the structure of space-time itself, and it has profound implications for time. Einstein showed that the speed of light is the universe's ultimate speed limit. Nothing with mass can reach it. Nothing can exceed it. Not because some cosmic law enforces the limit, but because at light speed, time itself stops. Photons, the particles of light, don't experience time. From a photon's perspective, if it had a perspective, its journey from emission to absorption is instantaneous. A photon emitted from a star 10 billion light-years away travels for 10 billion years from our perspective. But for the photon, no time passes at all. It's created and destroyed in the same instant. This reveals something profound about the structure of reality. Time and space are not separate. They're unified into space-time, and the speed of light is the conversion factor between them. 1 second of time equals 209,790, 458 meters of space. That's not an arbitrary relationship. It's built into the geometry of the universe. When you move through space, you're trading motion through time for motion through space. Sit perfectly still, and you're moving through time at maximum speed, 1 second per second. Move through space, and you're diverting some of that motion. The faster you move through space, the slower you move through time, until at light speed, all your motion is through space and none through time. Time stops. This unity of space and time means that the question, how fast am I moving through time, has a definite answer. At the speed of light, always. You're always moving through space-time at the speed of light. The only question is how much of that motion is through space versus time. This is why nothing can exceed the speed of light. It's not a speed limit in the ordinary sense, it's a rotational limit. You can rotate your motion from time into space, trading temporal motion for spatial motion. But once you've rotated all the way, once all your motion is through space and none through time, there's nowhere left to rotate. You've reached the absolute limit. But here's the strange part. While nothing can move faster than light through space, space itself can expand faster than light. During cosmic inflation, in the first 10^32 seconds after the Big Bang, space expanded exponentially, faster than light by many orders of magnitude. And even today, distant galaxies are receding from us faster than light due to the expansion of space. This doesn't violate relativity because the galaxies aren't moving through space faster than light. Space itself is stretching, carrying them along. The speed limit applies to motion through space, not to the expansion of space itself. This expansion creates a cosmic horizon, a boundary beyond which we can never receive information. Light from galaxies beyond this horizon is being carried away faster than it can travel toward us. We'll never see those galaxies. We'll never know what happens to them. They exist, but they're causally disconnected from us, separated by a growing gulf of expanding space. As the universe continues to expand and the expansion accelerates due to dark energy, more and more galaxies will cross this horizon and disappear from view. Eventually, in the far future, distant observers will see only their local galaxy cluster surrounded by darkness. All evidence of the larger universe will have vanished beyond their horizon. This creates a disturbing scenario: cosmological solipsism. Future civilizations with no knowledge of the cosmic expansion might conclude that their galaxy cluster is the entire universe. All the evidence we currently have for the Big Bang, cosmic expansion and dark energy will have literally moved beyond their reach. They'll be living in a universe that appears static and isolated, with no way to learn the truth. Unless they find ancient records, messages from earlier civilizations like ours, warning them that the universe is far larger than what they can observe. We might need to encode such messages, inscribe them in durable forms that will survive billions of years, just to tell future beings the truth about their cosmos. This connection between cosmic expansion and information loss hints at something deeper. The speed of light isn't just a speed limit, it's an information limit. It defines how fast information can propagate through the universe. And as space expands, information that was once accessible can become permanently inaccessible, lost beyond horizons that stretch faster than light. This makes Time's arrow even stranger. Not only does entropy increase, making the future different from the past, information also becomes more dispersed, more diluted as space expands. The universe is simultaneously becoming more disordered and more isolated, each region losing contact with more and more of the whole. In the far future, tens of billions of years from now, an observer in our galaxy would see a dark, empty universe. The cosmic microwave background would have cooled and redshifted beyond detectability. All other galaxies would have receded beyond the horizon. Stars would have burned out. Black holes would have evaporated through Hawking radiation. Space would be cold, dark, and nearly empty. And in such a universe, time itself would become meaningless. With no changes occurring, no events to mark progression, no way to distinguish one moment from another, the concept of time would lose its practical significance. The universe would enter a state of maximum entropy, where everything is in equilibrium and nothing ever happens. This is called the heat death of the universe, and it might be time's ultimate fate. The final tick. The heat death of the universe is not a dramatic explosion or a violent collapse. It's something far more eerie, a slow fade into absolute stillness. In this scenario, which most cosmologists consider the most likely fate of our universe, everything simply stops changing. It begins trillions of years from now. The last stars will have burned out. White dwarfs will have cooled to black dwarfs, dark and cold. Black holes will have evaporated through Hawking radiation, a process that takes 10 and 100 years for the supermassive ones. Protons themselves, the building blocks of ordinary matter, may decay after 10 or 34 years, dissolving atoms into radiation. What remains is a thin soup of photons and other particles, spreading ever more thinly as space continues expanding. The temperature approaches absolute zero. Energy becomes perfectly distributed, no longer flowing from hot to cold because there is no hot or cold anymore. Everything reaches the same temperature, the same state, equilibrium. And in equilibrium, nothing happens. No chemical reactions, no nuclear fusion, no work can be extracted, no structures can form. The universe becomes a featureless void of uniformly distributed energy, unchanging and unchangeable. This is maximum entropy, the ultimate victory of the second law of thermodynamics. And when entropy is at maximum, when there are no gradients left for energy to flow along, time's arrow disappears. There is no distinction between past and future anymore because nothing changes. Every moment is identical to every other moment. Does time still exist in such a universe? Mathematically, yes. You could still define a time coordinate, still write down equations describing the state at different times, but physically, experientially, time would be meaningless. There would be no way to measure it, no events to mark its passage, no observers to experience it. The universe would enter what physicist Max Tegmark calls the Big Bore, an eternity of nothing happening. Not the dramatic nothingness of empty space, but the boring nothingness of perfect equilibrium. And it would last forever, literally forever. No end, no change, no hope of anything ever happening again. Unless some physicists propose that even in maximum entropy, quantum fluctuations could occasionally create pockets of lower entropy. Given enough time, truly infinite time, anything that's physically possible will eventually happen. A random fluctuation might create a galaxy, or a star, or even a conscious observer complete with false memories of having lived before. These are called Boltzmann brains, named after physicist Ludwig Boltzmann. The idea is that in an infinite heat death, it's more probable for a single conscious brain to spontaneously assemble than for an entire universe like ours to form through normal processes. If you wait long enough, quantum mechanics allows anything consistent with the laws of physics to randomly occur. But this raises a disturbing question. If Boltzmann brains are more probable than normal observers like us, then statistically you're more likely to be a Boltzmann brain that just randomly assembled a moment ago, complete with false memories of a past that never happened, than to be a real person with an actual history. This is called the Boltzmann brain paradox, and it's genuinely troubling for cosmology. Most cosmologists think it's a sign that something is wrong with our understanding of the universe's far future, not that we're actually Boltzmann brains. But the fact that our best theories predict such absurdities suggests we're missing something important. Perhaps the heat death isn't the end. Perhaps the universe cycles, going through periods of expansion and contraction, each cycle ending in a big crunch that becomes the next big bang. Or perhaps our universe is just one bubble in an eternally inflating multiverse, constantly producing new universes with new starts even as older ones fade. Or perhaps time itself ends at heat death. Not because the universe stops existing, but because the very structure that creates time, entropy gradients and thermodynamic processes disappears. Without change, without processes unfolding, time becomes a coordinate without meaning, a dimension that exists mathematically but has no physical significance. Roger Penrose proposes something stranger still. In his conformal cyclic cosmology, the end of one universe becomes the beginning of the next, not through a physical process, but through a mathematical transformation. At heat death, when all matter has decayed and only photons remain, the universe loses its sense of scale. A photon doesn't experience time or distance, so a universe containing only photons is, in a sense, timeless and spaceless. Penrose suggests this timeless state is mathematically equivalent to the Big Bang of a new universe. The end becomes the beginning. Time doesn't end. It loops back, creating an infinite cycle of universes, each emerging from the heat death of the previous one. In this view, our Big Bang might have been the heat death of a prior universe, and our eventual heat death will be the Big Bang of the next. This is deeply speculative, but it offers a way out of the bleakness of eternal heat death. Time doesn't end. It renews, cycling endlessly, each universe living and dying in turn, phoenixes of space-time rising from their own ashes. But even if time cycles, even if the universe renews itself, there's a haunting question at the heart of all this. Why is there something rather than nothing? Why does time exist at all? The puzzle of existence. Before there was time, what was there? The question might be meaningless. Before presupposes time. If time began at the Big Bang, asking what came before is like asking what's north of the North Pole. The question contains a logical error, but quantum mechanics offers a way out. In quantum field theory, empty space isn't truly empty. It seethes with virtual particles, temporary fluctuations in quantum fields that pop in and out of existence. These fluctuations are real, they've been measured, and they have physical effects like the Casimir force. Some physicists, notably Lawrence Krauss in his book A Universe from Nothing, argue that our entire universe might be such a quantum fluctuation, one that happened to grow large through inflation instead of collapsing back into the vacuum. In this view, the universe emerged spontaneously from quantum uncertainty, no cause required. But this doesn't really explain why there's something rather than nothing. It just pushes the question back. Why do quantum fields exist? Why are there laws of physics that allow fluctuations? Why is there a quantum vacuum at all instead of absolute nothingness? Philosophers have wrestled with this for millennia. Leibniz asked why there is something rather than nothing, and answered that God chose to create the world. But that just shifts the question. Why does God exist? Some modern philosophers and physicists argue that existence is simply the default state. Nothingness would be a special condition requiring explanation. Why would there be nothing? What would enforce nothingness? Existence, by contrast, requires no enforcement. It just is. This is unsatisfying, but it might be as close as we can get to an answer. The universe exists because non-existence is not a stable state, or because existence is logically prior to non-existence, or because the question itself is malformed. But there's another possibility, one that connects to time in a profound way. Perhaps existence and time are the same thing. Not that they're identical, but that they're two aspects of a deeper unity. For something to exist is for it to persist through time. For time to exist is for things to persist, to endure, to have continuity from one moment to the next. In this view, asking why there's something rather than nothing is equivalent to asking why there's time rather than timelessness. And the answer might be that timelessness is actually impossible, that time is not a contingent feature of reality, but a necessary one, as inevitable as logic or mathematics. Some physicists pursuing quantum gravity have suggested that time is fundamental in a way that space is not. In Carlo Rovelli's loop quantum gravity, for instance, space is quantized and emergent, but time remains a background parameter. In other approaches called shape dynamics, time is the only absolute. Everything else, including the shape of space, is relative and emergent. If time is fundamental, if it cannot not exist, then the universe's existence becomes less mysterious. There must be time, and if there's time, there must be change, and if there's change, there must be something that changes. Existence follows from the necessity of time. This is speculative philosophy, not proven physics. But it suggests a deep connection between being and becoming, between existence and temporality. You can't have one without the other. Time is not something added to a static universe. It's the precondition for any universe at all. But here's the truly mind-bending possibility. What if our universe is a simulation? What if the time we experience, the changes we observe, the entropy that increases, is all computed, rendered moment by moment by some vast computational substrate outside our reality? The simulation hypothesis, popularized by philosopher Nick Bostrom, argues that if advanced civilizations can create detailed simulations of universes, and if they choose to run many such simulations, then statistically most conscious observers would exist inside simulations rather than in base reality. In other words, you're almost certainly living in a simulation. This sounds like science fiction, but it's taken seriously by some physicists and philosophers. If we were in a simulation, it would explain several puzzles. Why are the laws of physics mathematical? Because they're literally algorithms running on a computer. Why is there a cosmic speed limit? Because it prevents excessive computational demands, limiting how much the simulation has to compute at once. Why does quantum mechanics involve discrete states and probabilities? Because the simulation is quantized, running on discrete computational steps. Most provocatively, it would explain the nature of time. Time wouldn't be fundamental. It would be the iteration of the simulation's main loop, each tick of the universal clock corresponding to one computational step. The flow of time would literally be the universe's processor executing its code, one instruction at a time. In this view, the past doesn't exist anymore, and the future hasn't been computed yet. Only the present is real, held in the simulation's active memory. The rest is history, data compressed and stored, or not yet generated. This would explain why we experience a flow of time even though physics says past, present and future all exist equally. They don't, not in the simulation. Only the current frame exists. Can we test this? Some physicists have proposed looking for glitches or artifacts that would reveal the simulation's computational limits. If space-time is quantized, if energy levels come in discrete chunks, if there are fundamental limits to the precision of measurements, these might be signatures of an underlying computational substrate. But such evidence would be ambiguous. Quantum mechanics already predicts discrete energy levels and fundamental measurement limits. We can't distinguish between the universe is quantized because it's a simulation, and the universe is quantized because that's how reality works. Still, the simulation hypothesis forces us to take seriously a disturbing possibility. Everything you've experienced, every moment of time, every memory you have, might be rendered on the fly by a computer you'll never see, for purposes you'll never know. Time itself might be nothing more than a counter incrementing in some cosmic loop. Does this make time less real? Not necessarily. Even if we're in a simulation, time is still the structure governing how events unfold within the simulation. It's still the framework within which we exist. Calling it just a simulation doesn't diminish its reality for us, any more than calling physics just math diminishes the reality of falling objects. But it does suggest that time, like everything else, might be contingent. Not necessary, not absolute, but a feature of our particular reality, chosen by whoever or whatever created the simulation. In other realities, time might work differently or might not exist at all. This brings us full circle. We started by asking what time is. We've explored its flexibility, its connection to space, its emergence from quantum processes, its role in consciousness and causality. And we've discovered that time is far stranger, far more malleable, far less understood than we ever imagined. Now, in the final act of this journey, we're going to explore what time feels like when you stop thinking about it, when you let go of the questions and simply experience the flow, the passage, the quiet unfolding of moments. Because ultimately, understanding time intellectually is one thing, but experiencing time is something else entirely, and it's in that experience, in the felt sense of duration and change and becoming, that time reveals its deepest nature. Time crystals, matter that moves forever. In 2012, Nobel laureate Frank Wilczek proposed something that sounded impossible. A crystal that moves in time the way ordinary crystals are arranged in space. He called it a time crystal, and at first many physicists thought it violated the laws of thermodynamics. But in 2017, two teams of researchers independently created time crystals in their laboratories. A time crystal is a system that returns to its initial state periodically without expending energy. It's perpetual motion, but not the kind that violates conservation of energy. The system doesn't do work. It just oscillates forever, without any driving force. Here's how it works. Take a chain of atoms with their spins aligned. Blast them with a laser at a specific frequency. The atoms will flip their spins in response. But here's the strange part. They don't flip at the same frequency as the laser. They flip at half the frequency, or 1/3, creating a rhythm that persists even after the laser is turned off. This periodic behavior in time is analogous to how atoms arrange themselves periodically in space to form ordinary crystals. Just as a crystal's atoms repeat in a spatial pattern, a time crystal's state repeats in a temporal pattern. It's matter with a built-in beat, a rhythm that endures indefinitely. The existence of time crystals reveals something profound about time's structure. They show that time can have crystalline properties, discrete symmetries that repeat. This suggests that time, like space, might have a kind of grain, a fundamental periodicity at the quantum level. If time crystals can exist, what else might be possible? Could there be materials with more complex temporal structures, quasi-periodic time crystals that never exactly repeat? Time crystals in multiple dimensions, creating intricate temporal patterns. Some physicists speculate that time crystals might be useful for quantum computing. Their stable, repeating states could serve as quantum memory, resistant to decoherence because they're locked into a periodic cycle. Others suggest they might help us understand the nature of time itself, revealing that temporal structure is more complex and varied than we thought. But the mere existence of time crystals is profound. They're physical proof that time is not just a backdrop against which things happen. It's a dimension with structure, with properties, with behaviours as rich and strange as space itself. The cosmic calendar. To understand time's true scale, imagine compressing all 13.8 billion years of cosmic history into a single calendar year. On this cosmic calendar, the Big Bang occurs at midnight on January 1st. Our Sun forms on September 1st. Life on Earth begins on September 21st. And all of recorded human history fits into the last 14 seconds before midnight on December 31st. This is the cosmic calendar, popularized by Carl Sagan, and it reveals just how young we are, how brief our existence, how tiny our slice of cosmic time. The universe existed for 9 billion years before our solar system formed. It took 4 billion years for the first humans to appear. Written history, everything from the pyramids to the internet, is a literal eye blink in cosmic time. Let's walk through this calendar to appreciate time's vastness. January 1st, midnight, the Big Bang. The universe is born in a flash of energy and expansion. Within the first second, fundamental forces separate, particles form, the basic structure of reality crystallizes. January 10th, cosmic microwave background forms as the universe becomes transparent to light. This is the oldest light we can observe, the afterglow of the Big Bang. February. First stars ignite, massive and short-lived, fusing hydrogen into heavier elements. They explode as supernovae, seeding the cosmos with carbon, oxygen, iron. March to August. Galaxies form, merge, collide. The universe becomes a vast web of galaxies connected by filaments of dark matter. Black holes grow at galactic centres. Stars are born and die in enormous numbers. September the 1st. In a spiral arm of the Milky Way, a cloud of gas and dust collapses. Our Sun is born, along with a disk of material that will become planets. September the 2nd. Earth coalesces from the protoplanetary disk, a molten ball of rock and metal. The Moon forms from debris after a Mars-sized object collides with early Earth. September 21st. Life appears on Earth, simple single-celled organisms in the oceans. For the next 3 months, life remains microscopic and simple. October to November, life diversifies, but stays unicellular. Photosynthesis evolves, pumping oxygen into the atmosphere. The Great Oxygenation Event transforms Earth's chemistry. December 17th. The Cambrian Explosion. Complex multicellular life proliferates. Animals with shells, eyes, and nervous systems appear in the oceans. December the 26th. Dinosaurs evolve. They will dominate for 5 days on the cosmic calendar before an asteroid impact drives them extinct on December 30th. December 31st, 10:30 p.m. First hominids appear in Africa. Our ancestors diverge from other apes. 11:58 p.m. Modern humans, Homo sapiens, emerge. We've existed for 2 minutes of cosmic time. 11:59:46 p.m. Agriculture begins. Civilization starts. The last 14 seconds. 11:59:56 p.m. The pyramids are built. Ancient Egypt, Greece, Rome, all within the last 4 seconds. 11:59:59 p.m. The last second contains the Renaissance, the Scientific Revolution, the Industrial Revolution, both world wars, the space age, the internet, everything we call modern history. Midnight. Now. The end of the cosmic year. This perspective is humbling. Everything humans have done, every war fought, every empire risen and fallen, every work of art created, every scientific discovery made, all fit into a few seconds of cosmic time. We are newcomers to a universe that existed for billions of years without us and will continue for trillions more after we're gone. But there's another way to look at it. In those last 14 seconds, we appeared, looked around, and began to understand. We figured out the cosmic calendar itself. We traced time back to the Big Bang. We measured the universe's age, mapped its structure, predicted its future. In a cosmic eye blink, we went from ignorance to comprehension. That's remarkable. The universe spent 13.8 billion years evolving to the point where it could understand itself. And we're the mechanism by which it does so. We are the universe examining its own history, wondering about its own nature, contemplating its own fate. In this sense, our brief existence isn't diminished by cosmic time, it's dignified by it. We're not insignificant. We're the culmination of billions of years of evolution, the moment when matter becomes complex enough to reflect on itself. And here's what really keeps astronomers awake at night. According to the cosmic calendar, we're not just young, we're early. The universe is 13.8 billion years old, but it will continue for trillions of years. Star formation will peak and then slowly decline over hundreds of billions of years. The era of galaxies and stars might last 100 trillion years before the last star burns out. On that timescale, we're living in the very first moments of cosmic history. We appeared when the universe was less than 0.1% of the way through its star-forming phase. If the universe's entire history were a human lifetime of 80 years, we showed up 29 days after birth. Why so early? This is called the why now problem in cosmology. If intelligent life can arise at any point during the universe's star-forming era, why did we appear right at the beginning rather than billions or trillions of years from now? Maybe we're not early. Maybe we're typical, and intelligent life usually appears as soon as planets and chemistry allow. Or maybe we're lucky. Or maybe, disturbingly, there's a reason civilizations don't last long, a great filter that prevents them from existing for billions of years, cutting them off before they reach the cosmic late game. Or maybe time feels different at different cosmic epochs. Maybe what feels like early to us is actually the natural time for consciousness to appear, when stars are plentiful and planets are young and chemistry is vibrant. Maybe in the far future, when stars are rare and space is cold and dark, conditions won't favour the kind of complex chemistry that creates minds. If that's true, then we're not early, we're exactly on time. We appeared when the universe created conditions for consciousness, and when those conditions fade, so will consciousness, leaving the universe to run out its remaining trillions of years in silent darkness. Unless we figure out how to transcend those conditions, unless we learn to exist in forms that don't require stars or planets or chemistry, unless we become something other than biological organisms tied to a narrow range of temperatures and elements. This is the challenge facing any civilization that wants to survive cosmic time. You can't rely on stars forever. They'll burn out. You can't rely on planets. They'll freeze or be destroyed. You have to become something else, something that can exist in the cold, dark, empty universe of the far future. Some futurists imagine uploaded minds, consciousnesses running as software on computational substrates powered by black hole evaporation or dark energy. Others imagine beings made of fields rather than particles, patterns of energy that don't require matter at all. Still others imagine consciousness spreading across the cosmos, connecting distant nodes through quantum entanglement, becoming a distributed intelligence woven through space-time itself. These ideas are speculative, bordering on fantasy, but they point to a real question. If consciousness wants to outlast cosmic time, it will have to adapt, transform, become something we can barely imagine. The alternative is to accept that consciousness, like stars and planets, is temporary, a brief flowering in the universe's long history. And that brings us back to time, because one way to outlast time is to escape it. If you could somehow exist outside time, in a timeless realm where change is optional, you could persist forever without aging, without entropy, without the arrow of time dragging you toward dissolution. Is such a thing possible? Can anything exist outside time? The timeless realm. In quantum mechanics, there's a perspective called the Wheeler-DeWitt equation that describes the universe as a whole. In this equation, time disappears. There's no time variable, no ticking clock, just a static quantum state describing all possible configurations of the universe at once. This is called the problem of time in quantum gravity. When you try to apply quantum mechanics to the universe as a whole, time vanishes from the equations. There's no external clock measuring how the universal wave function evolves, because there's nothing outside the universe to hold the clock. From this perspective, the universe is timeless. It doesn't evolve, it just is, a superposition of all possible states, existing simultaneously in a quantum state that has no temporal extension. But this seems to contradict our experience. We clearly experience time flowing. So how do you reconcile a timeless quantum state with our experience of change? The answer involves decoherence and emergence. The universal quantum state might be timeless, but within it are subsystems like you and me that experience time because they're constantly decohering, constantly branching, constantly creating records and memories. Time emerges from the correlations between these subsystems. Think of it like a movie. The film itself is static, all frames existing simultaneously on the reel. But when you watch the movie, you experience it as unfolding in time because you're viewing the frames in sequence. The movie doesn't change, but your experience of it does. Similarly, the universe might be a timeless quantum state, but our experience of it is temporal because we're moving through it, sampling it moment by moment, creating the illusion of time flowing. This is one of the deepest ideas in modern physics. Time might not be fundamental. It might be an emergent property, something that arises from the way conscious observers interact with a timeless quantum state. If this is true, then in principle, you could access any moment of time simply by shifting your sampling point. The past still exists in the timeless quantum state. The future already exists there too. You're just not sampling those parts of the state right now. Some interpretations of quantum mechanics, particularly the many worlds interpretation combined with the Wheeler-DeWitt equation, suggest that all possible histories exist simultaneously in the universal wave function. Every choice you could make, every event that could happen, already exists in the timeless quantum state. You're just experiencing one particular path through that landscape of possibilities. This is vertigo-inducing. It suggests that everything that could happen has, in some sense, already happened, or rather, exists timelessly, waiting to be sampled by conscious observers like you. And if all moments exist timelessly, then time travel isn't about moving backward or forward through time. It's about changing your sampling point, shifting from one part of the timeless quantum state to another. This is highly speculative, but it shows how deeply strange time becomes when you take quantum mechanics seriously. Time might not be a flowing river, it might be a landscape, a terrain you navigate, but one that exists all at once without flow or direction. The multiverse of time. If many worlds is correct, then every quantum measurement causes the universe to split into multiple branches. One branch where the particle is spin up, another where it's spin down. One branch where you chose coffee, another where you chose tea. These branches are all equally real, but they can't communicate. They're separate timelines, separate histories, each unfolding according to its own sequence of quantum events. This means there are countless versions of you spread across the multiverse. In some branches, you made different choices. In others, historical events unfolded differently. In still others, the laws of physics are slightly different, or the initial conditions of the Big Bang varied, creating universes that look nothing like ours. What does this mean for time? It means time is not a single thread, but a vast tree, branching endlessly with each quantum event. Every moment contains infinitely many futures, all equally real, all equally part of the quantum wave function. From within any given branch, time appears to flow linearly. You experience one past and one present, and the future seems open. But from outside the multiverse, if such a perspective existed, there would be no single timeline, just an incomprehensibly complex structure of branching possibilities, each branch as real as every other. Some physicists suggest that the multiverse itself might be timeless. All branches, all moments, all possibilities exist simultaneously in the universal wave function. What we experience as the flow of time is just our consciousness moving from one branch to the next, sampling the multiverse one moment at a time. In this view, you're not moving through time. You're moving through the multiverse, hopping from branch to branch, always moving toward higher entropy branches because those are vastly more numerous. The arrow of time is just the arrow of probability, the tendency to move toward more likely states. This connects to something called the quantum mechanical arrow of time. In quantum mechanics, wave functions evolve deterministically forward in time according to the Schrödinger equation. But when a measurement occurs, the wave function collapses in a way that seems random and introduces an arrow of time. If many worlds is correct, the wave function never collapses. It just branches. And the branching creates the arrow of time because each branch carries less information about the others. Once you're in a branch, you can't access information from other branches. The past is fixed because it's the common trunk all branches share. The future is open because it's the space of possible branches. This is a beautiful way to think about time, not as something flowing, not as a dimension we move through, but as the structure of possibility itself. Time is the branching of reality, the constant creation of new worlds from every quantum event. And if this is true, then your life isn't a single timeline. It's a vast bush of timelines, spreading out from your birth, each branch representing a different sequence of choices and chances. Most branches are similar, nearby in the space of possibilities, but some are radically different, representing moments where your life could have gone in completely different directions. All these timelines exist. All these versions of you are real. They're just inaccessible to each other, separated by the branching structure of the multiverse. Does this mean every possible version of your life already exists somewhere in the multiverse? That somewhere you made different choices, lived a different life, became a different person? According to many worlds, yes. Every quantum event that could have gone differently did go differently in some branch. And since quantum events are happening constantly, trillions per second, the multiverse is unimaginably vast, containing versions of reality exploring every possibility allowed by the laws of physics. This is both comforting and terrifying. Comforting because every possibility is realized somewhere. Terrifying because it makes your choices feel meaningless. If every choice you could make is made in some branch, then why does it matter which branch you're in? But it does matter, because you're experiencing this branch. These are your memories, your relationships, your life. The other branches exist, but you're not in them. You're here in this timeline, and what you do here is real for you. The multiverse doesn't erase the significance of your choices. It just reveals that reality is far larger and more complex than you thought. Time isn't a single line, it's an infinite garden of forking paths, and you're walking one particular path through that garden. And here's the final mystery we'll carry into the last part of this journey. If time branches, if reality is constantly splitting into countless possibilities, then there might be branches where time itself works differently. Branches where it flows backward, or doesn't flow at all, or flows in multiple directions at once. Most branches are similar to ours because the laws of physics are the same. But at the boundaries, at the extreme edges of the multiverse, there might be regions where the rules change, where time is not what we know, where causality bends into strange loops, where past and future lose their meaning. We'll never visit those strange branches, but knowing they exist, knowing that our experience of time is just one possibility among infinitely many, changes how we think about the time we do have. Because time, as we experience it, is precious precisely because it's limited. We have one timeline, one sequence of moments from birth to death. We can't go back. We can't try different paths. We're committed to this branch, this version of reality moving forward moment by moment toward an unknown future. That constraint, that limitation, is what gives our choices weight. It's what makes moments matter. If you could live every possible life, if all choices were equally real in parallel branches, then nothing would be at stake. But you can't. You have one life, one timeline flowing in one direction. That's not a limitation. It's a gift. The experience of time, the river and the stone. Imagine standing beside a river. The water flows past you, always moving, never stopping. Each droplet that passes is unique, never to return. The river is time, and you are standing on its bank watching it flow. But here's the paradox. The river exists all at once, from its source in the mountains to its delta in the sea. From a bird's eye view, the entire river is present, a static shape carved into the landscape. The water isn't flowing when viewed from outside time. It just is a four-dimensional structure frozen in space-time. You, standing on the bank, experience the river as flowing because you're anchored to one location, to one moment. The water comes to you, passes you, and leaves. But the river itself doesn't move. You're the one moving through time, through the river's unchanging structure, experiencing it as flow. This is the paradox of time. It flows, yet it doesn't flow. It changes, yet it's unchanging. It moves forward, yet all moments exist simultaneously. How you experience time depends on your perspective, your frame of reference, your position in the river. The ancient Greek philosopher Heraclitus said you can never step into the same river twice. By the time you step in again, both you and the river have changed. The river flows, replacing its water moment by moment. You flow too, your cells dying and being replaced, your thoughts shifting, your memories accumulating. But there's another way to interpret Heraclitus. Perhaps you can never step into the same river twice because there is no same in time. Each moment is unique, unrepeatable, its own discrete point in the continuum. The river you step into the second time isn't the same river. It's a different river at a different moment, and yet we recognize continuity. The river is still the river, you are still you. Something persists across time even as everything changes. What is that something? Philosophers call it identity through change. Physics calls it conservation laws, properties that remain constant even as systems evolve. But neither explanation fully captures the mystery. Because the persistence of identity in time, the fact that you remain you despite every atom in your body being replaced over 7 years, is deeply strange. You're not the same physical matter you were a decade ago. Your cells have died and been replaced. Your memories have shifted, some fading, others strengthening. Your personality has evolved, and yet you are still you. Some thread of continuity connects your past self to your present self to your future self. That thread is time. Not time as a dimension in space-time, but time as the structure that allows identity to persist through change. Time is what makes you possible across multiple moments. It's the glue holding your life together into a coherent narrative. Without time, you would not exist. There would only be disconnected snapshots, moments without connection, experiences without an experiencer. Time creates the continuity that creates you. This is perhaps time's deepest function. Not to flow, not to measure duration, but to allow beings like us to exist, to have histories, memories, identities, to be more than instantaneous configurations of matter, to become entities that persist, that have pasts and futures, that accumulate experience and meaning. The river flows because that's its nature. You persist because time allows it. And in that persistence, in that continuity across change, something remarkable emerges. Consciousness, awareness, the sense of being a self that endures. The weight of moments. Not all moments are equal. Some pass unnoticed, forgotten as soon as they end. Others linger, heavy with significance, shaping everything that follows. Why? A moment becomes significant through attention and emotion. When you're fully present, when something moves you deeply, your brain encodes that moment more richly. More neural connections form. The memory becomes more detailed, more vivid, more durable. This is why childhood seems to last forever. Every experience is new, demanding attention, creating detailed memories. But as you age, routines set in. Days blur together. You encode less, and time seems to accelerate because you're creating fewer distinct memories per unit time. You can slow subjective time by paying attention, by seeking novelty, by being fully present. When you do this, moments gain weight. They stop being generic slices of time and become specific, irreplaceable, yours. This is why time in nature feels different. When you're hiking, really observing your surroundings, time slows. Each tree, each bird call, each shift in light receives attention. Your brain encodes richly. The hour feels full, substantial. But scroll through social media for an hour and afterward, you'll barely remember what you saw. Time will feel like it vanished because your brain didn't bother encoding most of it. The information was too rapid, too superficial, too similar from moment to moment. Attention is the currency of time. Where you direct it determines what you remember, how rich your experience feels, how full your life seems. Two people can live the same number of years, but one will have lived a much longer subjective life if they paid more attention, created more memories, experienced more deeply. This raises an interesting question. Can you extend your life by slowing subjective time? Not literally living more years, but experiencing more time within those years? The answer is yes. Through mindfulness, through novel experiences, through deep engagement with whatever you're doing, you can make time feel more expansive. An hour can feel like 3 if you're fully present. A day can feel like a week if everything is new and attention-grabbing. Conversely, you can waste time by not attending to it. Let years blur past in routine and distraction, and at the end you'll wonder where they went. You lived those years physically, but you didn't experience them fully. They passed without weight, without significance, leaving barely a trace. So in a very real sense, how much time you have is not just how many years you live. It's how deeply you experience those years. Quality of attention determines quantity of experienced time. This is not just psychology. It's reflected in how memory works. The brain doesn't store time directly. It stores events, and duration is inferred from how many events occurred. Pack more distinct events into a period, and it feels longer in memory. Let events blur together, and the period compresses. This is why vacation feels long while you're on it. Everything is new and attention-grabbing, but short in memory if it was relaxing and routine, and why a boring meeting feels eternal while it's happening. Attention to time itself but vanishes from memory afterward. Time, as you experience it, is constructed by your brain from attention and memory. It's not a passive reception of moments passing, it's an active process of encoding, interpreting, and reconstructing, and that means you have more control over time than you think. Not over time itself, not over the cosmic flow, but over your experience of it. And in the end, that's what matters. Because the time you experience is the only time you have. The silence between seconds. If you sit quietly and pay attention to your breath, something strange happens. Time stretches. The gaps between inhales and exhales feel long, spacious. Thoughts arise and pass. Sensations come and go. And in that simple attention to breath, time reveals a secret. It's not continuous, it's discrete. Your experience of time is built from discrete moments of consciousness, each lasting about 100 milliseconds. Your brain samples reality in pulses, like a video camera recording at 10 frames per second. What you experience as the smooth flow of time is actually a sequence of snapshots, stitched together so seamlessly you don't notice the gaps. But in meditation, when you slow down and pay close attention, you can feel the gaps. Moments of awareness separated by tiny intervals where nothing seems to be happening. The flow breaks apart into its constituent pulses. This is called the specious present, the duration of your immediate awareness. It's not instantaneous, it has width, about 2-3 seconds worth. Within that window, events feel simultaneous even if they're separated by a second or more. Your brain integrates them into a unified now. But beyond that window, time becomes past or future. Events that just happened feel already gone, receding into memory. Events about to happen feel uncertain, not yet real. This gives your experience of time a peculiar structure, a thick present, a specious now that's neither instantaneous nor eternal but something in between. A moving window about 2-3 seconds wide, gliding through time, constantly refreshing, carrying you from moment to moment. When you meditate deeply, this window can change. Experienced practitioners report that the present moment expands, becoming longer, more spacious. What normally feels like 2-3 seconds stretches to feel like 10, 20, even timeless minutes where past and future recede and only the present remains. This isn't mysticism, it's neuroscience. The brain regions that construct temporal experience, particularly the insular and prefrontal cortex, alter their activity during meditation. The sense of duration changes because the neural processes creating that sense have changed. You can experience this yourself. Sit quietly. Close your eyes. Pay attention to your breath. Nothing else. When thoughts arise, notice them and return to breath. Do this for 10 minutes, and you'll likely find that those 10 minutes felt longer than 10 minutes of scrolling or working. Not because clock time changed, but because you experienced it more fully. This is the paradox of time. The more you attend to it, the more you have. The less you attend, the faster it passes. Clock time is constant, but live time is flexible. And in those moments of deep attention, when time seems to slow or even stop, you glimpse something profound. Time is not an external force pushing you forward. It's an internal construction, a way your brain organizes experience. And like any construction, it can be modified, adjusted, even temporarily dismantled. What remains when time stops? Not nothingness, not a frozen moment, but pure awareness, consciousness without temporal structure, experiencing without the framework of past and future. This is what mystics have reported for millennia and what neuroscience is now confirming. Time can be optional for consciousness. Normally it's there, structuring every moment. But under certain conditions that structure dissolves, and you experience reality without time's mediation. This doesn't mean time stops in any objective sense. Clocks keep ticking, the universe keeps evolving. But subjectively, for consciousness, time can pause, and in that pause, you discover that you're not fundamentally a temporal being. You're aware of time, but you're not made of time. What you are, at the deepest level, is awareness itself. And awareness doesn't require time. It can hold time, structure time, experience time. But it exists whether time is flowing, stopped, reversed, or absent. This is perhaps the deepest answer to the question we started with. What is time? Time is the structure awareness creates to organize experience. It's real, but it's not fundamental. It's necessary for the kind of existence we have, but it's not necessary for existence itself. Awareness comes first. Time emerges from it. And in those rare moments when time dissolves, when the structure falls away, what remains is simply this: awareness, being, presence. Not the presence of a moment in time, but presence itself, timeless and complete. The archaeology of now, every moment you experience contains layers. Like sediment in rock, your present moment is built from the past, carrying traces of everything that came before. Your current thought arose from a previous thought. Your current feeling has roots in past experiences. Your body carries memories written in scars, in posture, in the way you breathe. You are an accumulation, a living archive of every moment you've lived. Neuroscientists have discovered that memory is not stored in discrete locations. It's distributed, woven through neural networks, patterns of connection that represent experiences. When you remember something, you don't retrieve a file. You reconstruct it, reassembling the pattern from scattered fragments. And each time you remember, the memory changes slightly. It's reconsolidated with new context, new associations. The past is not fixed in your brain. It's constantly being rewritten by your present moment. This means your history is not behind you, unchangeable. It's with you, evolving, being reinterpreted moment by moment. Who you were shapes who you are, but who you are also reshapes who you were. Time doesn't just flow forward, carrying the past behind it. Time loops back, with present constantly revising past and past constantly informing present. Consider a traumatic memory. When it first formed, it meant one thing. But years later, with therapy or new understanding, it can mean something different. The event hasn't changed, but its significance has. The past has been transformed by your present understanding. This is not just psychological, it's how memory physically works. The neural pattern representing that memory is different now than it was then. The past has literally changed in your brain. So when we ask where the past exists, the answer is strange. It doesn't exist in some distant realm of space-time, frozen and unchangeable. It exists here, now, in the present moment, encoded in memory, constantly being reconstructed and revised. You carry your entire past within you, not as static history, but as living influence, shaping how you perceive and respond to each new moment. The past is not gone, it's transformed into present structure, woven into who you are. And the future exists as anticipation, as expectation, as the forward momentum of intention. You're not just experiencing the present moment, you're also projecting forward, imagining what comes next, preparing responses, setting goals. Your brain is constantly generating predictions about the immediate future. When you reach for a cup, your motor cortex predicts the sensation of grasping it before contact occurs. When someone speaks, your auditory cortex predicts the next word before it's said. Your entire perceptual system is built on prediction, on models of what's about to happen. This means you're always slightly ahead of yourself, living a few hundred milliseconds in the future that your brain has projected. What you experience as now is actually your brain's best guess about what's happening right now, based on slightly outdated sensory information and predictive models. So the present moment contains 3 times: past encoded in memory and bodily structure, present arriving as sensory input, and future projected as prediction and anticipation. You don't live in a pure present, you live at the intersection of all three, a complex temporal landscape where past, present and future are constantly interacting. This is why be present is harder than it sounds. Your brain is designed to integrate temporal information, not to isolate single moments. Presence doesn't mean abandoning past and future. It means being aware of how they're operating in this moment, how memory is shaping perception, how anticipation is directing attention. True presence is not the absence of time. It's full engagement with time's complete structure in this moment. Knowing that past is here as memory, future is here as possibility, and present is here as awareness that holds them both. Duration and eternity. How long is now? That question has puzzled philosophers for millennia. If now is instantaneous, zero duration, then it doesn't exist. An instant without duration is a mathematical point, not an experience. But if now has duration, then it contains past moments, the beginning of now, and future moments, the end of now, which means it's not really now. St. Augustine wrestled with this paradox in the 4th century. He concluded that time exists only in the mind, as memory of the past, attention to the present, and expectation of the future. Physical time, he argued, doesn't actually exist. There are only mental states in an eternal present. This sounds mystical, but it's remarkably close to some modern physics interpretations. If time is emergent rather than fundamental, if it arises from consciousness organizing experience, then Augustine was onto something. The only time that exists is the time you experience. Everything else is abstraction. But what about eternity? Not infinite time, but timelessness. Existence outside time altogether. Mystics across cultures report experiences of eternity, moments when time seems to stop and they experience reality sub specie aeternitatis, under the aspect of eternity. These experiences are described as more real than ordinary experience, as if time is usually a veil and eternity is what lies behind it. Neuroscience offers a partial explanation. During certain meditative states, the brain's time processing regions deactivate. The sense of duration disappears. Without the neural machinery creating temporal experience, consciousness exists without temporal structure. This feels timeless because it is, at least neurologically. But maybe it's more than neurological. Maybe consciousness truly can access a timeless mode of being, one where the distinction between past, present and future dissolves. In the block universe view, all moments exist simultaneously. They're laid out in 4-dimensional space-time like a landscape. From within time you experience moments sequentially, but from outside time, if such a perspective exists, all moments are present at once. That external perspective would be eternal. Not lasting forever in time, but existing outside time, seeing all times at once. This is how some theologians describe God's perspective, how some physicists describe the view from outside space-time. We can't literally step outside time. We're temporal beings embedded in the flow, but we can imagine it, and in imagining it we glimpse something of what eternity might mean. It's not endless duration. That's just time extended indefinitely, which is still time. Eternity is the absence of time, the containing of all times, the perspective from which every moment is present without succession. And perhaps, in deep meditation or certain altered states, consciousness can touch that perspective, not by escaping time, but by recognizing that the deepest aspect of awareness is not bound by time even while it experiences time. This is the paradox of consciousness. You are in time, experiencing moments sequentially, but what experiences those moments, the awareness itself, seems not to be temporal. It doesn't age, doesn't change in the same way objects change. It simply witnesses, eternally present, while everything else flows. This witnessing consciousness is what remains when time is stripped away. Not nothing, but pure being. Awareness without content. presence without position in time. And recognizing this can change how you relate to time. Instead of being swept along by time's current, carried from moment to moment without choice, you can rest in the awareness that observes the current. You're still in the river, still experiencing time's flow. But you're also the bank, the stable point from which the flow is observed. The rhythm of everything time has rhythm, not just subjective rhythm, but physical rhythm woven into reality. Atoms vibrate at characteristic frequencies. Cesium atoms oscillate 9,431,231,770 times per second, defining our standard second. Photons oscillate as they travel, their frequency determining their colour. Your heart beats roughly once per second. Your breath cycles every few seconds. These rhythms are not arbitrary. They emerge from the fundamental structure of matter and energy. Atoms vibrate because electrons occupy discrete energy levels. Your heart beats because pacemaker cells discharge rhythmically. Your breath cycles because CO2 buildup triggers respiratory centers. Everything oscillates. Planets orbit, stars pulse, galaxies rotate. Even space-time itself might oscillate at the Planck scale, vibrating like a drumhead too tiny to observe directly. These rhythms create a kind of cosmic music, each object playing its note in a universal symphony. The ancient idea of the music of the spheres, dismissed as mysticism, turns out to be literally true. The universe is full of frequencies, oscillations, rhythms nested within rhythms, and these rhythms interact. When two systems have similar frequencies, they tend to synchronize. This is called entrainment. Your walking rhythm naturally synchronizes with music tempo. Your circadian rhythm entrains to day-night cycles. Even separate pendulum clocks mounted on the same wall will gradually synchronize their swings. Life is built on rhythm. Your neurons fire in synchronized bursts. Your cells divide on circadian schedules. Your body temperature, hormone levels, and metabolism follow daily cycles. You are a collection of oscillators, each with its own frequency, all coordinated into the complex rhythm we call life, and consciousness itself might be rhythmic. Brainwaves, the synchronized firing of millions of neurons, create patterns: delta, theta, alpha, beta, gamma. Each frequency corresponds to different states of consciousness. Deep sleep is dominated by slow delta waves. Alert focus produces fast beta. Flow states show theta patterns. When you meditate, your brain waves slow and synchronize. Different regions that normally oscillate independently begin pulsing together. This synchrony correlates with feelings of unity, timelessness, peace. The separate rhythms become one rhythm. Perhaps this is what meditation does. It tunes the brain's oscillators to a common frequency, creating coherence. And in that coherent state, the sense of time changes because the neural processes creating temporal experience have synchronized into a slower, more unified rhythm. The universe breathes. Galaxies pulse as stars ignite and die. The cosmic expansion is like a long, slow exhale that began 13.8 billion years ago and will continue for trillions more. And you breathe too, about 20,000 times per day, each breath linking you to that cosmic rhythm. The oxygen you inhale was forged in dying stars. The carbon in your body was created in stellar furnaces. You're made of stardust, rhythmically breathing, participating in the universe's vast metabolic cycle. Time is this rhythm, not a flowing river, but a pulse, an oscillation, a beating of the cosmic heart. Each moment is one beat, one cycle, one note in an endless song. When you feel time, you're feeling this rhythm. The succession of moments is like the ticking of a universal clock, but it's not mechanical. It's organic, alive, responsive. Time doesn't march uniformly. It breathes, swells, contracts, following rhythms within rhythms within rhythms, and you can tune into these rhythms. By paying attention to breath, you sync with your body's rhythms. By spending time in nature, you sync with circadian and seasonal rhythms. By meditating, you sync with the deeper rhythms of consciousness itself. The more synchronized you are, the more coherent time feels. Life flows smoothly when your rhythms align, with each other and with the world. Life feels chaotic when rhythms clash, when you're fighting against natural cycles. So part of living well is finding the right rhythms. Sleep-wake cycles that match your biology, work rhythms that match your energy levels, social rhythms that match your personality. When these align, time feels right. When they don't, time feels strained, exhausting. Time is not something imposed from outside. It's something you participate in through the rhythms of your life. And by choosing those rhythms wisely, by synchronizing with the pulses that sustain you, you can make time feel more natural, more yours. The patience of stars teach patience. They are born slowly, over millions of years, as gravity pulls together clouds of gas and dust. The collapse is gentle, gradual, grain by grain accumulating until suddenly fusion ignites and light is born. And then they burn, not quickly, not urgently, but with the patience of time itself. Our sun has been burning for 4.6 billion years. It will burn for another 5 billion. Each second, it converts 4 million tons of mass into energy. Yet this consumption is so measured, so steady, that it can continue for billions of years without exhausting itself. This is time on a cosmic scale. Not the frantic ticking of human hours, but the slow burning of stellar time, where 1 billion years is merely a phase, a chapter in a much longer story. When you look at a star, you're seeing light that left its surface minutes, years, or millennia ago, depending on the distance. The star you see is not the star as it is now. It's the star as it was then, its light travelling through time to reach your eye in this moment. The night sky is not a picture of now. It's a museum of the past, each star displaying itself at a different moment in history. Some of the stars you see no longer exist. They've already died, exploded, scattered their atoms into space, but their light is still travelling, still carrying the image of a star that exists only as a memory. This is time's strange property. Information can outlast its source. The past continues to exist as light, as radiation, as influence propagating through space. Even when the source is gone, its effects persist, echoing forward through time. You are like this too. The person you were years ago no longer exists in physical form. Every atom has been replaced. Every cell has been renewed. And yet, that past self continues to exist as influence, as memory, as the accumulated effects that shaped who you are now. You're your own light, travelling forward through time, carrying echoes of everything you've been, and those echoes will persist long after you're gone, in the people you've touched, the ideas you've shared, the small changes you've made to the world. This is a kind of immortality, not of body or consciousness, but of influence. Everything you do sends ripples forward through time, affecting futures you'll never see. A kind word today might change someone's trajectory, leading them to choices that affect others, cascading forward through generations. You're constantly creating the future through small actions whose consequences you cannot predict. A smile, a moment of patience, a thoughtful word, these seem minor, but time amplifies them. Over years, over decades, their effects compound, branching into outcomes you'll never know. So perhaps the question isn't how to make time last longer, but how to make the time you have matter more. How to create ripples that persist, that carry something valuable forward into the unknown future. Stars do this simply by existing, by burning, by creating light and heavy elements that will eventually form planets and life. They don't try to be significant, they just are, and their being radiates outward, touching everything. You can be like this too. You don't have to do something extraordinary. Just being present, being kind, Being genuine creates ripples. The authenticity of your presence matters more than the grand gestures you might plan. Time will carry your influence forward, whether you intended or not. The only question is what kind of influence you'll create. What ripples will you send into the future? What light will continue after you're gone? The Library of Moments. Imagine a library containing every moment of your life. Not descriptions, but the actual moments themselves, preserved somehow, accessible. You could walk down an aisle labelled childhood and pull a book from the shelf, open it, and be there, experiencing that moment again exactly as it was. In a sense, this library exists. It's called memory, though it's not nearly as organised or reliable as a real library. Your brain has stored fragments of countless moments, patterns of neural connections that, when activated, reconstruct experiences from your past. But the reconstruction is never perfect. Each time you remember, you're not accessing the original moment. You're creating it again, slightly different, influenced by everything that's happened since. The library is constantly being rewritten, books being edited, pages being shuffled or lost. And yet, something persists. The essence of experiences, the feelings they evoked, the meaning they held. Even if the details fade, the significance often remains. This is what time does to memory. It filters, distills, extracts meaning from experience. The trivial fades, the meaningful persists. Over years, your past becomes not a comprehensive record, but a curated collection, a greatest hits album of your life. And this is appropriate. You don't need to remember everything. Most moments are fungible, interchangeable, not worth preserving in detail. But some moments are crystalline, sharp, unique. These are the ones your brain fights to keep, reinforcing their neural patterns each time you recall them. What makes a moment worth remembering? Usually it's emotion. Strong feelings etch memories more deeply. Joy, fear, love, wonder. These create memories that last. Neutral moments, no matter how long they lasted, often leave barely a trace. This means your remembered life is not proportional to your lived life. A year of routine might compress in memory to almost nothing, while a single extraordinary week remains vivid forever. The life you remember is not the life you lived, but a selection, a compressed version that overweights the emotional and novel. And as time passes, this compression increases. Decades condense into a handful of scenes. You remember moving to a new city, but not the thousands of ordinary evenings spent there. You remember falling in love, but not most of the conversations that built that love. What remains is pattern and meaning. The feeling of a period of life, the lessons learned, the person you became. The details dissolve, but the essence persists. This is not a flaw of memory, it's a feature. Brains evolved not to record everything, but to extract useful patterns. The goal is not perfect recall, but effective navigation of future situations based on past experience. So your memory is not a library, but a teacher, constantly asking, what was important about that experience? What should I learn from it? What pattern does it reveal? And over time, the teaching becomes clearer. Distance provides perspective. Events that seemed random when they happened reveal patterns in hindsight. Difficulties that felt overwhelming at the time become the moments of greatest growth when viewed from years later. Time is not just carrying you forward, it's also continuously reinterpreting your past, finding meaning you couldn't see when you were living it. This is why older people often speak of events from decades ago as formative, even if they didn't seem so at the time. Time has done its work distilling experience into wisdom, so don't worry if you're forgetting details. The details don't matter as much as you think. What matters is the meaning you've extracted, the person you've become, the patterns you've recognized. These are what persist, what travel forward with you through time. And in the end, this is what your life will become. Not a sequence of moments, but a pattern of meaning, a story told by the person you became, written in choices made and lessons learned, red in the eyes of those who knew you, seasons and cycles. The earth turns, day becomes night becomes day. This is the most fundamental rhythm of life, the cycle that entrains all others. Your body knows it, carries an internal clock synchronized to this 24-hour pulse. Even in the absence of light, deep in caves or isolated rooms, your circadian rhythm persists, about 24 hours give or take. Your body knows when to sleep, when to wake, when to be alert or sluggish, all following this internal sun. This is ancient. Single-celled organisms have circadian rhythms. Plants have them. Animals have them. The 24-hour cycle is not just learned or cultural, it's biological, encoded in genes, expressed in proteins that oscillate with daily regularity. You are a being of rhythm, tuned to the Earth's turning, participating in a dance as old as life itself. Each sunrise resets your clock, pulls you back into synchrony with the planet. Each sunset triggers cascades of melatonin, preparing you for rest. This is not just human time, it's Earth time, the time that all surface life shares, the rhythm we evolved within and cannot escape. And beyond the daily cycle, there are longer rhythms. The moon waxes and wanes, 29.5 days from new to new. Tides follow, oceans breathing in and out. Some animals time their reproduction to lunar phases. Some plants flower by moonlight. Your body feels these longer cycles too, though more subtly. Monthly hormonal rhythms, particularly in women, echo the lunar month. Energy levels vary. Mood shifts. Attention waxes and wanes like the moon itself. And then the seasons. Earth's axis tilts, and as the planet orbits the sun, seasons march their slow parade. Spring's awakening, summer's abundance, autumn's harvest, winter's rest. Each season lasting months, long enough that you adapt, forget the others, until the cycle turns again. These seasonal rhythms shaped human evolution. Our ancestors' survival depended on reading seasonal signs, knowing when to plant, when to harvest, when to prepare for winter's scarcity. This knowledge is in you still, encoded not just culturally but biologically. You feel it. The energy of spring, the laziness of summer, the melancholy of autumn, the introspection of winter. These are not just psychological, they're biological responses to changing light, temperature, and food availability, responses that served ancestors for millennia. Modern life tries to erase seasons. Electric lights defy darkness. Climate control maintains eternal spring. Food arrives from around the world year-round, erasing seasonal scarcity. You can live as if seasons don't exist, but your body knows. It still responds to day length, still shifts with solstices, still feels the pull of ancient cycles. And when you ignore these rhythms, when you push against them, demanding summer energy in winter or winter rest in summer, you feel the friction. Perhaps living well means respecting these cycles. Sleeping when dark, rising with light, resting in winter, being active in summer, eating foods in season, moving with the planet's rhythms rather than against them. Time is not just a line from past to future, it's also a circle, cycles within cycles, rhythms that return, seasons that repeat. The day you're living now is not just today, it's also a return to all previous todays, and the echo of every morning you've ever experienced. And tomorrow will come, as it always has, bringing another turn of the wheel, another chance to participate in these ancient cycles that connect you to all life, all beings who've danced to Earth's rhythm. There's comfort in this. The cycles don't end. Winter always gives way to spring. Night always becomes day. Even in darkness, you can trust that light is coming. Even in difficulty, you can trust that change is constant, that no season lasts forever. This is the wisdom of cycles. Nothing is permanent except change itself, and change follows patterns, rhythms you can learn and trust. Time is not chaos, It's dance, with steps that repeat, movements you can anticipate and flow with. So when you're struggling, remember, this too shall pass. The season will change. The cycle will turn. Difficult times are temporary, part of a larger pattern that includes ease, joy, and renewal. And when times are good, enjoy them fully, knowing they too are temporary, part of the same cycle. Don't cling or grasp. Just be present, grateful for this season, this moment, this particular turn of the wheel. The speed of soil forms slowly. Rock weathers, crumbles, organisms die, decay, become humus, minerals and organic matter mix. Over decades, over centuries, soil deepens millimetre by millimetre, almost imperceptibly slow. This is geological time. Not the quick time of human doing, but the patient time of Earth's processes, where change is measured in strata, in layers laid down century by century. A forest grows on this soil. Trees rise over decades, mature over centuries. Some live hundreds of years, witnessing generations of animals, cycles of fire and flood, all while remaining rooted, patient, growing. When you stand in an old-growth forest, you're surrounded by beings who measure time differently. That tree has seen hundreds of years pass. It was a seedling when your great-great-great-grandparents were young. It will likely be here long after you're gone. This perspective is humbling. Your entire life is a brief moment to the tree. Your decades of worry and striving, your carefully accumulated accomplishments, they're barely a season in forest time. And the forest itself is young compared to the mountains that frame it. Those peaks rose over millions of years, thrust upward by tectonic forces too slow to see. They've been weathering, eroding, shifting for longer than forests have existed, longer than most species have existed. This is deep time, the time of geology and evolution, where significant change takes millions of years. The time in which new species emerge, continents drift, ocean basins open and close. From this perspective, all of human history is a blink. Civilization itself, everything from the first cities to the internet, fits into 10,000 years. Agriculture is 12,000 years old. Anatomically, modern humans are only 300,000 years old. A footnote in Earth's 4.6 billion year story, and Earth itself is young compared to the universe. The planet formed 9 billion years after the Big Bang, in the middle of cosmic history. Stars and galaxies much older than our solar system exist, their light travelling billions of years to reach us. This nesting of timescales is dizzying. Your heartbeat, your day, your year, your life, human history, civilizational time, geological time, planetary time, cosmic time. Each scale dwarfing the previous, each revealing that what seemed long is actually brief, and yet each time scale is equally real, equally valid. The urgency of your heartbeat is not less important because stars burn for billions of years. Your life is not meaningless because geological processes are longer. Each scale has its own logic, its own relevance. You live in human time, and that's the time that matters for you. The decisions you make, the relationships you build, the moments you experience, these unfold in human time and should be honoured as such. But knowing the larger scales provides perspective. When you're stressed about deadlines, remember the mountain outside your window. It's been there for millions of years. It will be there long after your deadline passes. This doesn't make the deadline unimportant, but it frames it differently. When you're grieving a loss, remember the forest. Trees die. The forest continues. Death is part of the cycle, not an aberration. This doesn't erase the grief, but it situates it within a larger pattern of endings and beginnings. When you're celebrating an achievement, remember the soil beneath your feet. It was built from countless deaths, countless endings becoming beginnings. Your success too is part of a larger process, standing on foundations laid by others, becoming a foundation for what comes next. Time exists at many scales simultaneously. You can zoom in to the intensity of this moment, this breath, this heartbeat, or zoom out to the patience of mountains, the slow turning of seasons, the vast arc of cosmic evolution. Both perspectives are true. Neither cancels the other. You're simultaneously a brief flicker and an eternal participant in processes that span billions of years. Your molecules were forged in stars. They will return to stars eventually. Right now, they're configured into you, experiencing this moment, this particular arrangement of stardust that is aware of itself. This is the miracle and the mystery. Not that time is short or long, but that it exists at all, structured in scales that allow beings like you to emerge, to experience, to wonder about time itself. Waiting for water moves slowly through stone. Rain falls, it seeps into soil, percolates down through layers of earth and rock. It encounters aquifers, vast underground reservoirs held in porous stone, and there it stays, years, decades, sometimes centuries, moving so slowly that its progress is measured in meters per year, invisible to any observer, patient beyond human comprehension. Eventually it emerges, a spring, a seep, water returning to the surface after its long underground journey. The water you drink today might have fallen as rain when your grandparents were children. It has been travelling slowly, patiently, through darkness, through stone, waiting to return to light. This is water's time, the time of seepage and accumulation, of patient flow through resistance, of journeys too slow to imagine yet inevitable. Rivers are faster, but still patient. They carve canyons over millions of years, grain by grain wearing away stone. The Grand Canyon is water's monument, a mile-deep testament to the power of patient persistence. The Colorado River didn't force its way through that rock. It simply flowed, day after day, year after year, millennium after millennium. And stone, hard as it is, could not resist forever. It yielded gradually, allowing water to carve its passage. This is the patience that creates lasting change. Not force, not urgency, but consistent gentle pressure applied over time. Water doesn't fight stone, it just keeps flowing, and eventually stone becomes canyon. You can learn from this. The changes you want to make, the person you want to become, the life you want to build, these don't require dramatic force. They require consistency. Patient daily effort, like water on stone. Each day's effort might seem insignificant. You're not visibly different today than yesterday. But over months, over years, the accumulation becomes apparent. You've carved your own canyon, shaped yourself through persistent, gentle effort. This is hard to remember in a culture of urgency, of quick results, of overnight success stories. We're taught to want instant change, immediate results, and when they don't come, we despair, give up, start something new. But real change is slow. Lasting transformation takes time. The tree doesn't grow fast, it grows slowly, adding one ring per year, patient and persistent. And eventually it's tall, strong, able to withstand storms that would topple a younger tree. You're building yourself the same way. Each day is one ring, one layer, one small addition to the structure of who you're becoming. You won't see progress day to day, but year to year, the accumulation is undeniable. So be patient, be like water, keep flowing, keep seeping, keep wearing away at the obstacles slowly, gently, persistently. Trust that time is working with you, that consistent effort compounds, that patience is not passive but powerful. The stone will yield. Not today, not this week, but eventually. Water always finds its way through. Not because it's strong, but because it's patient. Not because it forces, but because it persists. And when you've carved your canyon, when years of patient effort have created something beautiful and lasting, you'll understand what time really is. Not an enemy to be rushed through, not a limitation to be fought, but an ally, a medium in which transformation occurs, a canvas on which persistence paints its slow and beautiful art. The silence of snow falls silently, each flake unique, intricate, perfect in its geometry. Sixfold symmetry born from the molecular structure of water, crystallized in cold air, drifting down to rest. It accumulates, flake by flake, layer by layer, each one infinitesimal, together creating drifts, blanketing the ground, transforming the landscape into white silence. Snow muffles sound. Walking through fresh snow, the world becomes quiet. Noise absorbs into the soft surface. Even your footsteps sound different, cushioned, muted. This is winter's gift. Silence, slowness. The world blanketed, resting, waiting. Life doesn't stop, but it slows, conserves, turns inward. Trees stand bare, their growth paused. Animals den, hibernate, or move slowly to conserve energy. Even the light is different. Lower, softer, the sun's arc shorter and weaker. Winter is time's rest, the exhale after autumn's harvest, the pause before spring's renewal, a season for stillness, for reflection, for the slow work of internal change that isn't visible from outside. In modern life, we resist this. We maintain summer's pace year-round, electric lights defying winter's darkness, climate control maintaining constant temperature, activity pushed to the same intensity regardless of season. But the body knows winter. It wants to slow down, to rest more, to turn inward. Fighting this natural rhythm creates friction, fatigue, a sense of pushing against something fundamental. Perhaps winter's teaching is to respect rest, to honour the pause, to recognise that not all times are for doing. Some times are for being, for stillness, for the silent work of integration and renewal. Seeds rest in winter. They don't grow, they wait, dormant, using this pause to prepare for spring's burst. Without winter's rest, spring's growth wouldn't be possible. The pause is not wasted time, it's necessary time, essential to the cycle. You need this too. Times of rest, of dormancy, of apparent non-productivity. These aren't failures or wastes. They're necessary phases in growth, times when change happens invisibly, internally, preparing for future expression. Our culture doesn't value this. It celebrates constant activity, constant productivity, constant growth. Rest is seen as weakness, as laziness, as something to minimize and apologize for. But this is unsustainable. Constant growth is cancer's pattern, not life's. Healthy systems cycle between growth and rest, activity and dormancy, expansion and consolidation. The seasons teach this. Spring's explosion of growth is funded by winter's rest. Summer's abundance draws on spring's energy. Autumn's harvest is possible because summer grew and ripened. Winter's stillness prepares for spring's return. Each season is necessary. None is better or more important. They're phases in a cycle, each with its own gifts, its own work to do. So when you're in a winter phase, don't fight it. Don't berate yourself for not being productive, not making visible progress, not growing at summer's pace. Winter has its own work. Rest, integration, preparation. Honour it. The snow will melt, spring will come. But trying to force spring during winter doesn't work. It just creates exhaustion and frustration. Trust the cycle. Trust that winter's rest is not wasted but essential. And when you're in winter, when life has slowed and the world is quiet, take the gift being offered. Rest. Be still. Let yourself be blanketed in silence. Do the invisible internal work that prepares for future growth. The snow falls silently, each flake unique, each one necessary to the whole. You are like this too. Each moment of rest is accumulating layer by layer, creating the foundation for what comes next. Trust the accumulation. Trust the silence. Trust winter's wisdom. The patience of stone sits. For millions of years stone sits. Rain falls on it, wind scours it, ice cracks it. Slowly, imperceptibly, stone weathers. Atoms detach, grain by grain becoming soil. This is the slowest change. Geological time, the time in which mountains rise and erode, continents drift, ocean floors spread. Time so vast that human consciousness can barely grasp it. A stone you hold in your hand is older than civilization, older than humanity, often older than most species currently alive. It has existed, unchanged in any visible way, through ice ages and warm periods, through the rise and fall of countless generations of life. And yet it's not eternal. Even stone changes, even mountains erode. The Appalachians were once as tall as the Himalayas. Time has worn them down, gentle but inexorable, reducing mighty peaks to ancient rounded hills. Nothing resists time forever. Stone, diamond, metal, all eventually yield. The question is not whether change happens, but how fast. And compared to stone, you are incredibly fast. Your life flickers past like lightning compared to stone's slow endurance. You move, think, change, grow old and die in what is to stone an instant. This could be depressing. But consider, in that instant you experience vastness. You love, learn, create, connect. You accumulate memories, build relationships, make meaning. Your brief existence contains more richness than stone's billion years. Stone endures but does not experience. It exists but does not live. You, fragile and temporary as you are, have something stone lacks. Awareness, consciousness, the ability to know that you are, to reflect on existence, to find meaning in the brief time you have. This is the strange reversal. Stone's eternity is empty. Your moment is full. Duration is not the same as depth. You can live more in decades than stone lives in eons. So don't envy stone's endurance. Stone does not experience its own persistence. It simply is, unchanging, unaware, patient not by choice but by nature. You are different. You experience time. You feel it passing. You make choices about how to spend it. And that awareness, that agency, makes your brief time infinitely more valuable than stone's eternity. Still, stone teaches something important. It teaches persistence without urgency. Stone doesn't hurry. It doesn't stress about its slow weathering. It simply endures moment by moment, responding to conditions without resistance. When rain falls, stone gets wet. When sun shines, stone warms. When ice forms in cracks, stone eventually splits. There's no fighting, no anxiety about these changes. Stone accepts what comes, responds as its nature dictates, and continues. You can be like this too. Not stone's passivity, but its non-resistance, responding to life's conditions without fighting reality, accepting what comes while staying true to your nature, persistent without hurrying, patient without being passive. Stone's time and your time are different, but both are valid. You don't need to last as long as stone to matter. Your brief time is enough, more than enough, if you fill it with awareness, with presence, with meaning. And when your time ends, when your body returns to Earth, the atoms that made you will persist. They'll become soil, become other beings, continue the cycle. Your particular arrangement will dissolve, but nothing is lost. You'll rejoin the elements, patient as stone, waiting to become something new. The forgotten language of hours before clocks, humans told time differently. They watched the sun's arc, the star's rotation, the changing angle of shadows. They knew time through the body, hunger, fatigue, waking, sleeping. Time was not divided into uniform units. An hour in winter felt different from an hour in summer because daylight hours changed. Morning and evening were not fixed clock times but relative positions of the sun. This was unequal time, where hours stretched and contracted with the seasons. A daylight hour in summer was longer than in winter, because daylight itself was longer. Night hours were opposite, longer in winter, shorter in summer. This seems imprecise to us now, accustomed to clocks that divide time into identical units regardless of season or latitude. But unequal time was actually more natural, more aligned with how life works. Your energy changes with daylight. More sunlight means more wakefulness, more activity. Less sunlight means more rest, more slowness. Following clock time means fighting these natural variations, pushing for the same output regardless of season. But your ancestors didn't do this. They woke with sunrise, slept after sunset. Winter days were shorter, so they did less, rested more. Summer days were longer, so they worked more, slept less. They followed the rhythm of light, adapting to seasonal changes rather than imposing arbitrary uniformity. This was not laziness. It was wisdom, an understanding that energy is seasonal, that pushing equally hard year-round is unsustainable. Modern life has forgotten this. We work the same hours winter and summer, maintain the same schedules regardless of light. We impose mechanical time on biological bodies that still respond to daylight, still feel the seasonal pull, and we wonder why we're tired in winter, why motivation is harder when days are short. The body knows, it wants to rest more, but we override this wisdom with coffee and artificial light, pushing through instead of adapting. Maybe we need to remember unequal time, not abandoning clocks, but using them more flexibly, respecting the body's seasonal changes. Sleeping more in winter isn't laziness, it's biological necessity. Working less when energy is low isn't failure, it's sustainability. The ancient division of day into 12 hours of daylight and 12 hours of darkness regardless of season recognized that time is not uniform. The measure changed with the seasons because the experience changed. We've lost this flexibility. Clock time is uniform, abstract, disconnected from bodily experience. An hour is always an hour whether you're alert or exhausted, energized or depleted. But subjectively, hours are never equal. An hour of focused work feels different from an hour of distraction. An hour with a loved one feels different from an hour alone. An hour in joy feels different from an hour in pain. Clock time measures duration, but it doesn't measure experience. And experience is what actually matters. You don't live clock time. You live felt time, experiential time, the time that your consciousness inhabits. So perhaps the teaching is this. Honor felt time as much as clock time. When you're tired, rest, regardless of what the clock says about how many hours you've worked. When you're energized, create, even if it's supposed to be rest time. This doesn't mean ignoring commitments or schedules. It means recognizing that clock time is a tool, not a tyrant. Use it for coordination, for meeting others, for structuring activities. But don't let it override the wisdom of your body, the natural rhythms that tell you when to push and when to rest. Time is not just what clocks measure. It's what bodies feel, what consciousness experiences, what life unfolds within. Reclaim that older, wiser relationship with time. Follow the light, honor the seasons, listen to the body's wisdom. The forgotten language of hours speaks in sunrise and sunset, in hunger and satiation, in wakefulness and fatigue. It speaks in seasons changing and days lengthening and shortening. Learn this language again. It's older than clocks, truer than schedules, more aligned with who you actually are. The tea ceremony of time. In the Japanese tea ceremony, every movement is deliberate. Water is heated slowly. Tea is whisked with precise motions. Each gesture has been refined over centuries, distilled to its essence. The ceremony can take hours, not because it's complex, but because it's slow. Intentionally, ceremonially slow. Every action is given the time it needs, no more, no less. This is time as ritual, as sacred, pause, as the deliberate creation of slowness in a world that always hurries. The tea ceremony doesn't fight time, it expands it, stretches each moment so it becomes spacious, full, complete in itself. When you're in the ceremony, time changes, clock time continues, minutes passing as they always do, but felt time expands. Each moment becomes thick, rich, substantial. An hour in the ceremony feels longer than an hour of rushing, because you're actually present for it. This is the paradox of slowness. When you slow down deliberately, you experience more time, not less. Rushing collapses time, makes it disappear. Slowness expands it, makes it tangible. You can create this in ordinary life without formal ceremony. Just slow down. Do one thing at a time, completely. Wash dishes as if washing dishes is the only thing that matters. Walk as if walking is a destination in itself, not just transport between places. When you do this, time stretches. 5 minutes of mindful dishwashing feels longer, more substantial than an hour of distracted scrolling. You're actually present for those 5 minutes, while the hour evaporates into vague memory of nothing in particular. This is time's strange math. More presence equals more experienced time. Less presence equals less experienced time, regardless of clock duration. So if you want more time, slow down. Not literally, not reducing what you do, but reducing how fast you do it. Give each thing the time it deserves. Do it completely, attentively, without already moving mentally to the next thing. This is incredibly hard in modern life. Everything pushes towards speed, efficiency, multitasking. We're taught to save time, optimize time, never waste time. But what is wasted time? Time not experienced? Time that evaporates because you weren't present for it. By that measure, rushing wastes time, because you're not actually there for the moments you're supposedly saving. The tea ceremony teaches another way. That time is not something to save or spend, but something to inhabit. That the point of having time is not to fill it with as much as possible, but to experience it as fully as possible. One moment of full presence is worth more than hours of distraction. One truly experienced hour contains more life than days of going through motions without awareness. So perhaps the question is not how to have more time, but how to inhabit the time you have more fully, how to be present for it, awake within it, meeting each moment as it is rather than always reaching toward the next. This doesn't mean doing everything slowly. Sometimes quickness is appropriate, even necessary. But even in speed, you can be present, aware, engaged. The tea ceremony isn't about slowness for its own sake, it's about deliberateness, about choosing each action, about being fully present for what you're doing. You can wash dishes like the tea ceremony. You can walk like the tea ceremony. You can work, rest, eat, speak, all with that same quality of presence, that same honouring of the moment you're in. And when you do, time changes. Not clock time, but felt time. The texture of your days becomes different, richer, more substantial, more real. You're not adding hours to your life, you're adding life to your hours. And that's what matters. Not duration, but depth. Not length, but fullness. Erosion and Grace Canyon walls show their history. Layers of stone, each one a different age, different composition, tell millions of years of story. This layer, ancient ocean sediment. That layer, volcanic ash. Another, desert sand turned to stone. And through it all, the river cut. Slowly, patiently, creating depth through erosion. Taking away rather than adding. Revealing what was hidden beneath. This is time's other work, not just building and accumulating, but eroding and revealing, taking away the unnecessary, wearing down the excess, slowly exposing the essential. You are eroded too by time, not just aging, not just the physical wearing away, but a deeper erosion. Life's experiences wear away pretense, illusion, false self-images. Time reveals what's actually there beneath the surface constructions. When you're young, you present many faces, Try on many identities, build elaborate structures of who you think you should be. But time erodes these. Slowly, experiences wear away what doesn't fit, what isn't authentic, what was always pretense. What remains is closer to truth, not perfect, not complete, but more real. The essential self, exposed by erosion, the way canyon walls expose ancient layers of stone. This erosion can feel like loss. You lose certainties, lose the easy answers, lose the comfortable identities you'd constructed. But what you're losing was never truly you. It was surface, sediment, covering what was deeper. Time is generous in this erosion. It doesn't take what's essential. It only takes what was false. And it does this slowly, gently, giving you time to adjust, to recognize that what's being revealed is more true than what's being taken away. This is grace. Not the grace of easy fortune, but the grace of patient revelation, the slow work of time exposing your actual nature beneath the accumulated layers of conditioning and pretense. Old age is often described as diminishment. Bodies weaken, capabilities fade. But there's another perspective. Old age is erosion complete, the person fully revealed, all pretense worn away. What remains is essence, undeniable, unmistakable. This is why old faces are beautiful in a way young faces aren't. Young faces are still hidden beneath smooth surfaces, potential not yet revealed. Old faces are landscapes, showing every erosion, every layer, the full history visible in lines and textures. And old people, if they've allowed the erosion, if they haven't fought time's revealing work, often have a quality of genuineness that younger people lack. They're simply themselves, no longer maintaining elaborate facades, no longer worried about presenting acceptable images. Time has done its work. The canyon is cut. The essential person stands revealed. This is both comforting and challenging. Comforting because you don't have to maintain pretense forever. Time will erode it anyway, slowly removing what doesn't fit. But challenging because erosion requires letting go, allowing time to take what it will, trusting that what remains will be truer, if not larger. You can resist this. You can fight erosion, try to maintain all your surfaces, rebuild what time takes away. But this is exhausting, ultimately futile. Time is patient and persistent. It will erode what needs eroding, whether you cooperate or not. Or you can cooperate. You can allow the erosion, even welcome it. Let time take what's false. Let experiences wear away what isn't actually you. Trust that what remains will be worth keeping, that essence is stronger than pretense, that truth is more beautiful than surface. This is time's gift if you can accept it. Not the gift of accumulation, but the gift of revelation. Not adding more, but revealing what was always there, beneath the layers, waiting to be exposed. The canyon is beautiful because it's been eroded. The layers are beautiful because they're revealed. You too will become beautiful this way, if you let time do its work. Not beautiful like youth, smooth and unopened, but beautiful like canyon walls, layered and deep, every line telling a story, every erosion revealing truth. The waiting room. Waiting is where time becomes visible. Usually time passes unnoticed, filled with activity, attention directed outward. But in waiting, time slows, becomes tangible, present as presence. You sit in a waiting room, nothing to do but wait. Minutes stretch. You become aware of duration in a way you normally aren't. Each minute is felt, counted, noticed. This is uncomfortable at first. We're not accustomed to empty time, to duration without content. We reach for phones, magazines, anything to fill the space, to make time disappear again into distraction. But what if you don't? What if you just sit with waiting, with time itself, allowing it to be empty, allowing yourself to experience duration without needing it to be filled? This is meditation's core practice. sitting with time, not filling it, not doing anything in particular, just being present for duration as it unfolds, breath by breath, moment by moment, and something remarkable happens. The discomfort fades. Time becomes less heavy. You're not fighting it anymore, not wishing it would pass faster. You're just there, with time, in time, experiencing its passage without resistance. This is acceptance, not passive resignation, but active allowing. Time is passing. You're waiting. These are facts, neither good nor bad. You can suffer them by resisting, or you can meet them as they are, without overlay of judgment or preference. And in that meeting, time changes quality. It's still passing, still duration, but it's no longer oppressive. It's just what's happening, this unfolding of moments, this gradual progression from past to future. You're breathing. That's happening. Your heart is beating. That's happening. Thoughts arise and pass. That's happening. Time is passing. That's happening. All of it just happening, without needing to be different. This is the peace that's available in any moment. Not the peace of desired conditions being met, but the peace of acceptance, of stopping the fight against what is. Waiting teaches this. Forced stillness teaches this. Any situation where you can't make time pass faster teaches this. You can suffer, wishing it were different, or you can accept, meeting what is without resistance. And acceptance doesn't mean liking. You don't have to enjoy waiting. You just have to stop fighting it. Let it be what it is. Let time pass at its own pace. You're not in control of that. You never were. This is humbling but also freeing. You're not responsible for making time pass, for filling it, for optimizing every moment. Time passes on its own. Your only choice is how you meet it, with resistance, and it's heavy, oppressive, something to endure, with acceptance, and it's just what's happening, neither good nor bad, just the neutral unfolding of duration. Breathing continues, heart beats, time passes, all of it automatic, requiring nothing from you. You can relax into this, let it happen. Trust that nothing you need to do can make time pass faster, and nothing you need to avoid can make it pass slower. Time is time. It moves at its pace, which is the only pace it's ever moved, the only pace it ever will move. This pace is perfect, not because it's desirable, but because it's what is. Reality is always perfect in this sense, not as judgment but as description. What is what is, perfectly what it is, without deviation or error, so you can relax, stop fighting time, stop trying to speed it up or slow it down. Just let it be, and let yourself be within it, not separate, not struggling, just here, now, breathing, waiting, being. The waiting room is everywhere. Every moment is a waiting room, time passing, you present within it. Sometimes there's activity to fill it, sometimes there's nothing to do but wait. Both are fine, both are just time passing, moments unfolding, you present within them. And in this presence, this acceptance, this allowing of what is, something loosens, the heaviness lifts. Time is no longer an enemy or a burden. It's just the medium you exist within, like fish in water, birds in air. You don't fight it, you swim in it, fly through it, simply being what you are within the medium that holds you. The mathematics of breath. Your breath has a rhythm. In, out, pause, in, out, pause, roughly 12 to 20 times per minute when you're at rest. Slower when you sleep, faster when you move. This rhythm is automatic. You don't decide to breathe. Your brainstem handles it, monitoring blood, chemistry, adjusting rate and depth to maintain balance. Carbon dioxide rises and breathing deepens. Oxygen is sufficient and breathing slows. This is your body's clock, ticking not in seconds but in breaths. About 20,000 breaths per day. About 7 million breaths per year. Over a lifetime, hundreds of millions of breaths, each one a small cycle, a miniature tide of air moving in and out. You can become aware of this rhythm at any time. Just notice breath. Don't change it. Don't control it. Just observe. Air moving in, air moving out. Pause. Again. In this observation, time becomes visible. Each breath is one unit of time, one cycle in the ongoing rhythm. You can count breaths instead of seconds, measure duration in inhalations, experience time as the pattern of breathing. Ancient meditation traditions use breath this way, not as something to control, but as something to anchor awareness to. Because breath is always happening, always accessible, always in the present moment. You can't breathe yesterday's breath. You can't breathe tomorrow's breath. Breath only exists now. So attending to breath naturally brings you into now, into the only moment that actually exists. This is why breath is the foundation of meditation. Not because breath is special, but because it's present, automatic, rhythmic. It's time made tangible, duration you can feel directly, moment by moment. And when you rest attention on breath, thinking slows. The mind's constant movement toward past and future quiets. You're just here, breathing, experiencing the simple fact of being alive in this moment. Nothing needs to be different. Nothing needs to be fixed or improved. You're breathing, which means you're alive. That's enough. That's complete. Everything else is extra, overlay, stories you tell about what should be different. But breath knows none of this. It continues, indifferent to stories, maintaining life without commentary. In, out, pause. The same pattern it's followed since your first breath at birth, the same pattern it will follow until your last breath at death. In the space between those two breaths, your first and your last, thousands of days unfold, millions of breaths, a lifetime of moments, and in each moment breath is there, quiet, reliable, marking time, keeping life going. You can trust breath. It doesn't fail. It doesn't forget. Even when you're unconscious, even when you're not thinking about it at all, breath continues, faithful and constant. This is time's kindness. It requires nothing from you. It unfolds automatically, carrying you along whether you're paying attention or not. You don't have to manage time. You don't have to optimize it. Time takes care of itself, and breath, which marks time, takes care of itself too, so you can relax. Let breath breathe itself, let time pass itself. You're carried along, supported, held in a process that's been reliable since before you existed and will continue after you're gone. Breath by breath, moment by moment, time unfolds, and you're here for it, witnessing it, experiencing it, simply by being alive, by breathing, by allowing what's already happening to happen. The stillness of ice water freezes slowly. Temperature drops, molecules lose energy, movement slows. They begin to arrange themselves into crystalline patterns, each water molecule finding its place in the lattice. The process spreads gradually, ice forming from edges inward, from surface down. Hours passing, energy dissipating, motion becoming structure, liquid becoming solid. Frozen water is not dead. It's transformed, molecules still vibrating but locked in position, potential energy stored in the rigid lattice, waiting. This is winter's secret. Stillness is not absence, it's potential concentrated, energy conserved, life paused but not ended. The frozen lake holds summer's water, unchanged in essence, waiting for warmth to release it. You can be like this. Times when activity ceases, when forward motion stops, when everything seems frozen. These are not endings, they're transformations, energy taking different form, potential accumulating in stillness. Ice is patient. It doesn't fight its frozen state. It simply is ice, completely, accepting the temperature that shaped it. And when warmth comes, it releases easily, flowing again, becoming water without resistance. You can resist your frozen times, fighting the stillness, desperate to be in motion again. Or you can be like ice, accepting the state you're in, trusting that warmth will come when conditions allow. Nothing is permanent. Ice melts, water freezes, states change as conditions change. Fighting the current state doesn't change it faster. It just creates suffering, resistance against what is. But accepting doesn't mean liking. You don't have to enjoy being frozen. You just have to stop fighting it. Be frozen completely if that's what's happening. Be still fully if that's what's required. And in that acceptance, something interesting happens. The stillness becomes less oppressive. It's just a state, temporary like all states, neither good nor bad. Just what's happening right now. Beneath the frozen surface, life continues. Fish swim slowly in cold water. Plants rest, roots alive beneath frozen ground. Seeds wait in the soil, gathering energy for spring's burst. Stillness is not emptiness, it's concentration, potential compressed, energy stored. Like a drawn bow, like a coiled spring, like water held as ice, stillness contains possibility. So when you're in a still time, where nothing seems to be moving or changing, trust that beneath the surface, unseen processes are happening. Energy is accumulating. Potential is building. The next phase is being prepared, even if you can't see evidence of it yet. Ice knows it will melt. It doesn't worry about staying frozen forever. It just is ice. For however long, ice is what's required. And then, when warmth comes, it flows. You can trust this too. The frozen. Time won't last forever. Change is constant, even when it's not visible. Warmth is coming, conditions are shifting, and when the moment arrives, you'll flow again naturally, easily, without needing to force it. Until then, be ice, be still, be patient, conserve energy, rest in the knowledge that this state, like all states, is temporary. Spring follows winter as surely as thaw follows freeze. Time moves through seasons, you move through seasons. Both require all phases, activity and rest, flow and stillness, water and ice. Honor the phase you're in. It's necessary. It's part of the whole. The library dreams are made of dreams collapse time. In sleep, hours compress into moments, or moments expand into hours. Linear time dissolves, replaced by dream logic where past and future intermingle, where you can be young and old simultaneously, where impossible juxtapositions feel perfectly natural. This is consciousness without time's usual structure. The brain, freed from the task of navigating physical reality, plays with temporal sequence, creating narratives that defy clock time but feel coherent within the dream. You've experienced this. A dream that feels like it lasted hours occurs in the 20 minutes between alarm cycles, or a brief dream image persists in memory more vividly than yesterday's waking events. Dream time is not clock time. It's psychological time, symbolic time, the time of meaning rather than measurement. In dreams, a childhood home can coexist with your current life. A deceased relative can be present and alive. Separate timelines merge without contradiction. This reveals something about consciousness. The sense of linear time, the clear distinction between past and future, is something your waking brain constructs. It's not fundamental to consciousness itself. Awareness can hold multiple times simultaneously when the constructing mechanism relaxes, and maybe waking life is more like dreams than we admit. Memory constantly rewrites the past. Imagination constantly creates possible futures. Present perception is always delayed, always a reconstruction. The clean timeline we think we inhabit is more constructed than we realize. Dreams make this obvious. Awake, we maintain the illusion of linear time through effort, through the constant work of organizing perception into temporal sequence. But that organization is voluntary, maintained, not inherent. In deep meditation, time can become dreamlike too. The clear boundaries between moments blur. Past, present, and future seem less separated. You might have memories that feel present, or present experiences that feel already remembered. This isn't pathology. It's the natural state of consciousness when the organizing structures relax. Time is more fluid, more flexible than our daily experience suggests, and perhaps death is like this too. The temporal structures that organize waking consciousness dissolving, allowing awareness to exist without the constraints of linear time. Past and future simultaneously accessible, all moments present at once. This is speculative, unknowable, but dreams offer a glimpse. Every night you experience consciousness without normal temporal structure. Every night you prove that awareness doesn't require linear time to exist. So maybe the flow of time we experience when awake is optional. Maybe it's a tool consciousness uses for navigating physical reality, but not a fundamental feature of consciousness itself. In dreams, you're still you. Your awareness persists, but the temporal structure is different, more fluid, less constrained, and you accept this easily. Dream logic makes sense within dreams, even when it would be absurd awake. Perhaps waking life is one mode of consciousness among many, one way of organizing experience useful for its purposes but not the only way. Dreams show another mode, where time is flexible and symbolic rather than linear and literal. And maybe there are other modes too, modes we access in meditation, in altered states, possibly in death. Ways of being conscious that don't follow waking time's rules. None of this makes waking time less real. It's real within its context, serving its function. But it might not be absolute, not the only way consciousness can relate to time. Dreams whisper this truth nightly. Time is negotiable. Structure is optional. Consciousness predates and underlies temporal organization, capable of existing with it or without it, linear or fluid, constrained or free. The space between thoughts. Thoughts arise. They don't come from anywhere you can identify. They just appear, emerging from silence into awareness. An image, a word, a feeling, suddenly present where nothing was before. And then they pass. They dissolve back into the silence they came from, leaving no trace. Another thought arises, different from the first, equally unexplained in its origin. This is the mind's natural rhythm. Thoughts appearing and disappearing, arising and passing, the whole process automatic, requiring nothing from you. But between thoughts, there's silence, brief, usually unnoticed but always there. A gap, a space, a moment of no thought between one thought and the next. In meditation, you begin to notice these gaps. You're watching thoughts, observing them arise and pass, and occasionally you catch the space between them, the silence before the next thought forms. This silence is remarkable. It's not empty, it's full, aware, present. But it's free of content, free of the constant mental chatter that normally fills awareness, and in that silence, time stops. Not literally, not clock time, but the sense of time passing, the feeling of moving from past to future, that stops. Because that feeling is created by thoughts, by the constant flow of mental content marking progression. Without thoughts, without content, there's just awareness, present, timeless, not moving anywhere because there's nowhere to move to. Just this, just now, complete in itself. This is what mystics point to when they speak of the eternal present. Not a moment in time, but the space between moments, the awareness that's always here, always now, regardless of what thoughts or experiences are arising within it. You've experienced this. Moments of absorption where you lose track of time, where you're so focused, so present, that hours pass like minutes. Except they don't pass like anything. They just are, and you're there with them beyond time. These moments are glimpses of the space between thoughts. When thoughts slow enough, when gaps widen, you fall into timelessness. Not as a special state, but as what's always here, normally obscured by constant thinking. And this timelessness is not nothing. It's not unconsciousness or absence. It's presence itself, awareness without content, being without doing. The simple fact of existing before thought adds commentary about what that existence means. You can access this at any time. Just watch thoughts. Don't engage with them, don't follow them, just notice them arising, notice them passing. And in the watching, gaps will appear, spaces between thoughts, moments of pure awareness. These moments are brief at first. Thought quickly resumes, filling the space with new content, but with practice the gaps lengthen. Silence becomes more familiar. You learn to rest in it rather than rushing to fill it. And in that resting, time transforms. The urgency drops away. The sense of needing to get somewhere, to become something, to achieve before time runs out, all of that relaxes, because you're not actually in time. You're in awareness, which contains time but is not bound by it. Time is something that happens within awareness, like weather happening within sky. Sky doesn't move with the weather. It holds it, contains it, remains itself regardless of what's passing through. You are like sky. Thoughts like weather. Time like the movement of weather systems, real and observable, but not affecting what you fundamentally are. This is hard to grasp conceptually. It's not a concept. It's direct experience, available in the space between thoughts, in moments of pure awareness uncomplicated by mental content. And once you've found it, once you've rested in that timeless space even briefly, something changes. You know directly that you're not just a being in time, you're also the awareness that witnesses time, that contains it, that exists before and after time does its work. This doesn't make time unreal. Time is real within its domain. But you're not limited to that domain. You have access to something else, something prior, something that was never born and will never die because it exists outside time's jurisdiction. The benediction of dusk, daylight fades slowly. The sun's angle lowers, light becomes golden, shadows lengthen. The world softens, edges blur, harsh contrasts dissolve into gentle gradients. This is dusk, the transition time, neither day nor night, but something in between. A liminal hour when the world shifts from one state to another, gradually, gracefully, giving you time to adjust. Birds sing their evening songs, nocturnal creatures begin to stir, day animals settle. The changeover happens smoothly, one world fading as another emerges. Dusk teaches transition. Nothing ends abruptly. Day doesn't stop and night begin. They blend, overlap, one gradually becoming the other, through this transitional phase we call twilight. Your life has dusks too, times of transition, neither fully in one phase nor the next, between jobs, between relationships, between ways of being. These liminal times can feel uncomfortable, undefined, unclear, but they're necessary. Like dusk, they give you time to adjust, to shift from one mode to another gradually. Abrupt changes are jarring, gradual transitions are kind, and in the transition there's often beauty. The special light of dusk, neither day's clarity nor night's darkness, a unique quality that exists only in the in-between. Your transitional times might have this quality too, a particular awareness that comes from being between states, from not being fully committed to old or new, from existing in that fertile uncertainty where change is possible. Dusk is brief, half an hour, maybe an hour depending on latitude and season. Then night arrives fully, the transition complete. But that brief time holds a particular grace, a softness, an allowance for change. When you're in transition, when you're in your own dusk, honour it. Don't rush to night. Don't cling to day. Be in the dusk fully, accepting the in-between state, trusting that it will naturally progress to what comes next. The light is different in dusk. Colours shift. What was invisible in bright daylight becomes visible in softer light. What was clear becomes mysterious. This isn't worse than daylight. It's different, offering its own kind of seeing. In your transitions, you might see differently too. Perspectives that weren't available in the bright certainty of the previous phase. Questions that emerge only when old answers no longer fit. Possibilities visible only when you're not committed to a particular direction. This is transition's gift. Not the destination, but the journey between destinations. Not day or night, but dusk. The beautiful, uncertain space where anything could happen next. And like dusk, your transitions will end. Night will come, the new phase will stabilize, and you'll wonder why you were ever uncertain. But while you're in it, while you're in the transition, try to appreciate the unique quality it offers. Because you can only be in dusk when you're in dusk. Once night arrives, dusk is gone. And while you're in it, it's beautiful in its own way, worthy of attention, deserving of patience. The world doesn't demand that dusk hurry up and become night. It allows dusk to be dusk for however long it needs to be. You can allow your transitions the same courtesy. Be in between. Be uncertain. Be in flux. It's temporary, like all states, and it has its own gifts to offer before it passes. The weight of stones in your pocket. Imagine carrying stones. Not large ones, just pebbles. Each one representing something you're holding on to. A grudge, a regret, a worry, a should have been. At first, one pebble is no burden, you barely notice it, but you collect more. Each day, each experience, adding another stone to your pocket, a sharp word received, an opportunity missed, an unkindness given or received. The weight accumulates, your pocket grows heavy. You walk bent under the burden, not realizing that you're the one adding stones, that you're the one who could choose to empty your pocket. Past events become stones when you won't release them. When you replay them, rehearse what you should have said, imagine different outcomes. The event is over, it's gone, but you're keeping it alive, keeping it present, carrying it with you as weight. This is what not accepting time does. It turns past into burden. Events that should be released, allowed to pass, get frozen and carried forward. And the weight increases until you can barely move for all the stones you're hauling. But you can empty your pocket, not by forcing forgiveness or positive thinking, but simply by recognizing that you're choosing to carry what you could release. That grudge, it's a stone. You can put it down. The event happened, yes. It's part of your history, but you don't have to keep rehashing it, don't have to maintain it as an active presence in your current life. That regret, stone. You can acknowledge what happened, learn from it, and release it. Carrying it forward doesn't change the past, it just makes the present heavier. This doesn't mean forgetting. Memory remains, but there's a difference between remembering something and carrying it. Remembering is neutral, factual. Carrying is active, maintaining weight. You can remember without carrying. Acknowledge the past without letting it burden the present. Hold memory lightly instead of gripping it, maintaining it, feeding it energy. Every moment you choose, add stones or release them. Carry forward or let go. Make the present heavy with past or meet it fresh, unburdened. And the choice is constant. You can't make it once and be done. Every moment offers the same question. Carry or release, hold or let go. Mindfulness is the practice of noticing the stones, becoming aware of what you're carrying, what weight you're maintaining. Just noticing doesn't immediately release it, but notice is the first step. Because you can't release what you don't realize you're carrying, and you're carrying more than you think. Years of accumulated stones, some so familiar you've forgotten they're there. But you can feel the weight, the heaviness of always being slightly burdened, slightly bent, slightly struggling under a load you can't quite identify. What if you emptied your pockets? Not all at once, necessarily, but one stone at a time, consciously releasing what no longer needs to be carried. This person wronged you? Yes, but carrying that forward doesn't protect you, doesn't change them, doesn't help. It just weighs you down. You can release it. Not for them, for you. You made a mistake. Acknowledged, learned from, now release it. Carrying it doesn't undo it, doesn't prevent future mistakes. It just makes you heavier. Stone by stone, lighten your load, not by pretending the past didn't happen, but by accepting that it did happen and choosing not to maintain it as current weight. The past is already past. You don't have to work to keep it so. It naturally recedes, naturally becomes less present, unless you actively maintain it. Keep it alive, carry it forward. So stop carrying. Let it recede. Let time do what time does, which is carry events away, dissolve their sharp edges, integrate them into history rather than keeping them active in present experience. Your pocket can be empty. Your walk can be light. Not because nothing difficult has happened, but because you've learned to release what's already gone, to honour the past without being burdened by it. This is time's teaching. Let what's past be past. Don't carry it into present. Don't let it colour future. Meet each moment fresh, unburdened, ready for whatever comes without the weight of all that's gone before. The stones are yours. The choice to carry or release is yours. Every moment you can lighten your pocket or continue collecting weight. Time offers the opportunity. The choice is always now. The loom of days. Imagine your life as fabric being woven. Each day is a thread, each moment a crossing of weft and warp. The pattern emerges slowly, line by line, each addition small but the whole gradually revealing design. You can't see the full pattern while you're weaving it. You're too close, too involved in the detail of this particular thread, this specific crossing. The overall design is hidden, visible only to someone standing back, seeing the whole. But you're weaving continuously. Each choice is a thread. Each action adds to the pattern, and the choices seem small, the actions seem insignificant, but they accumulate. Thread by thread, line by line, the fabric grows. This is time's work, not dramatic transformations, but accumulation, the steady addition of thread to thread, moment to moment, day to day. And from this accumulation, patterns emerge. You don't decide the pattern consciously. You make individual choices, place individual threads, but the overall design emerges from the sum of those choices in ways you can't predict. Years later, you look back and see pattern. See how this led to that, how these choices wove together to create that outcome, how the random seeming threads actually formed coherent design. This is hindsight, the ability to see pattern in what felt random when you were living it, the ability to recognize design in what seemed like chaos. But the design was always there, emerging thread by thread, visible only in retrospect. You were weaving it all along, each small choice adding to the pattern, though you couldn't see what you were creating, and the weaving continues. Right now, you're placing threads. They seem small, these daily choices, these ordinary moments, but they're accumulating. The pattern is forming, even though you can't see it yet. Years from now, you'll look back at now and see pattern. You'll recognize how today's choices led to tomorrow's outcomes, how these threads you're placing now created the design that will become visible later. But you can't force pattern. You can't decide in advance what the design will be. You can only keep weaving, keep placing threads, trusting that pattern will emerge from faithful daily practice. This is the paradox of intention and surrender. You choose the threads, the colours, the placements, but you don't control the overall pattern. That emerges from forces larger than your conscious choice, circumstances, chance, the choices of others, the way threads interact in ways you can't predict. So you weave with intention, but without attachment to outcome. You place each thread as carefully as you can, choosing colours that seem right, making patterns that seem beautiful. But you release control of what those choices will create in the long run, because you can't know. The full pattern is too large, too complex, involving too many threads not under your control. You weave your part, trusting that it will integrate with all the other threads into some larger whole. And this is okay. This is how it works. You're not meant to see the whole pattern while you're weaving it. You're meant to focus on this thread, this moment, this choice. The pattern will take care of itself. Your part is to keep weaving, to show up each day, to place your threads with care, to do the best you can with the colours and materials you have. The rest, the overall design, that's not your responsibility. It will emerge. It's already emerging. But you won't see it clearly until much later, when enough fabric has accumulated that the design becomes visible. So don't worry about the pattern. Focus on the thread. This moment, this choice, this small addition to the fabric. Do it with care, with attention, with integrity. And trust that thread by thread, moment by moment, day by day, a life is being woven. A pattern is emerging. A design is forming that will be visible eventually, beautiful in ways you can't imagine yet. Keep weaving. That's all. Just keep weaving. The return to silence. All sound returns to silence. A bell rings, vibrations spread through air, reach your ear, register as sound, and then the vibrations dissipate. Energy spreads into surrounding space. The sound fades. Silence returns. The silence was there before the sound. It remains after the sound. The sound is temporary, a brief disturbance in silence's eternal presence. Time is like this. Activity arises, events happen, things change. But these arise from stillness, occur within stillness, return to stillness. Stillness is always there, the ground from which activity emerges and to which it returns. Your life is sound in silence, activity in stillness, movement emerging from rest, returning to rest, and the rest, the stillness, the silence. That's not nothing. It's the canvas, the space, the ground that makes activity possible. Without silence, there is no sound. Without stillness, there is no movement. The two aren't opposites. They're complementary, interdependent, each necessary for the other. In meditation, you learn to hear silence, not as absence of sound, but as presence. The background that's always there, normally unnoticed beneath layers of sound, revealed when sound's quiet enough that you can perceive what holds them. And time works this way too. Beneath the activity, beneath the constant change, there's something still. Something that doesn't move or change, that simply is, constant and present, witnessing all the movement happening within it. This stillness is your deepest nature, not the active, changing you that moves through life, makes decisions, experiences events, but the aware presence that witnesses all of this, that remains constant through all changes. When you die, activity ceases, but maybe stillness remains. Maybe what you essentially are, that aware presence, that witness that continues, returns to the silence it never truly left. This is speculation, comfort perhaps, but it makes a certain sense. If awareness is fundamental, if it's not produced by brain activity but rather channeled or expressed through it, then cessation of brain activity wouldn't end awareness. It would just end this particular expression of it. Like sound fading into silence. The silence was always there. The sound didn't create silence or destroy it. It just arose within it temporarily, a brief disturbance, a momentary expression, before returning to the ground from which it came. You might be like this, a temporary expression of eternal awareness, arising, living, experiencing, and then releasing back into the source, not ending but transforming, returning to what you always were beneath the temporary form. But whether this is true or not, whether any of us continues past death, there's still value in recognizing stillness now, in learning to rest in the silence beneath sound, the stillness beneath activity, the presence beneath the constant flux of experience. Because that presence is available now. That stillness is here now. That ground is beneath you now. You don't have to wait for death to touch it. You can find it in life, in moments of deep rest, of meditation, of quiet presence. And touching it changes how you relate to time. The urgency decreases. The fear of time running out loosens. Because you've touched something timeless, something that doesn't depend on having more time, something that's complete right now. Not more time, just this time, this moment, completely experienced, fully present, resting in awareness that doesn't need anything to be different. This is enough. This is complete. Sound or silence, activity or rest, time or timelessness. It's all happening within something that holds it all, contains it all, remains itself throughout all changes. And that's something, that aware presence, that might be what you essentially are. Not the person moving through time, but the awareness experiencing that movement. Not the sound, but the silence that makes sound possible. Listen for that silence, not by making everything quiet, but by recognizing what's beneath the sound. What was there before? Sound arose. What remains after sound fades. That's where you rest. That's what you are. That's home. The dissolving edge. Where does your body end and the world begin? The question seems obvious. Your skin is the boundary, separating inside from outside, you from not you. But look more closely. Your skin is porous, constantly exchanging molecules with air. You breathe in oxygen that becomes part of you. Breathe out carbon dioxide that becomes part of the air. Where's the boundary? You eat food and it becomes you. You shed skin cells and they become not you. The molecules that compose you are constantly cycling, leaving and entering, making the boundary between you and world permeable, temporary, undefined. So where exactly do you end? At your skin? Inside your skin? If molecules are constantly exchanging, is there any fixed boundary at all? And extend this to time. You're different today than you were years ago. Different molecules, different cells, different thoughts. So is past you the same person as present you? Where's the temporal boundary between one version of you and another? These questions reveal something. The boundaries we take for granted, spatial and temporal, are conventions, useful fictions, not absolute truths. At close examination they dissolve. You blend into world, past blends into present. Everything interconnects in ways that defy clear separation. This isn't mysticism, it's physics. Every atom in your body was forged in stars. The iron in your blood, the calcium in your bones, the carbon in your cells, all stellar products scattered by supernovae, eventually accumulating into you. You're made of stars, literally. The universe assembled you from its own substance, and when you die, those atoms return to circulation, becoming other forms, other beings, continuing in the endless cycle of matter, becoming different configurations, so you're not separate from the universe. You're a temporary configuration of it, a pattern it's expressing for a while, before reorganizing into different patterns. And time is the dimension in which this reorganization happens, the axis along which patterns emerge, persist, dissolve, and re-emerge in new forms. You are pattern, not substance. The substance was always here and always will be. But the pattern that is you, that's temporary, arising and passing like all patterns do. This could be depressing, but consider, every pattern is equally temporary, equally an expression of underlying substance arranging itself. Stars, galaxies, mountains, rivers, trees, animals, humans, all patterns, all temporary, all equally real and equally ephemeral. Nothing lasts forever as pattern. But the substance that creates patterns that remains, constantly reconfiguring, creating new patterns as old ones dissolve, you're part of that process. You're the universe patterning itself into a form that can look at itself, think about itself, experience itself. For a brief time, matter becomes aware through you, and then it reorganizes, and awareness expresses through other forms, so your boundaries in space and time are soft. You blend into worlds spatially, into past and future temporally. You're not a separate thing, but a process, a pattern, a temporarily coherent configuration of the same stuff that makes everything else. This recognition can be freeing. You're not isolated, not alone, not truly separate from anything. The boundaries you defend so carefully are already permeable, already dissolving at every moment. You can relax into this. Let the boundaries soften. Recognize your continuity with everything around you, everything before and after you. You're part of the flow, not separate from it. And in that recognition, something loosens. The desperate grip on self, on maintaining boundaries, on preserving your particular pattern forever. Because you can't. The pattern is already changing, already dissolving and reforming with each moment. But what you're made of, that continues. And what you're aware through, that awareness, maybe that continues too. Not as your particular pattern, but as the capacity for pattern to be aware, the universe's ability to experience itself through countless temporary forms. You're one of those forms. Unique, yes. Valuable, yes. But not separate, not isolated, not different in kind from everything else. Just different in current configuration, current pattern, current expression. And that's enough. That's complete. Being a temporary pattern in an eternal flow, aware for this brief time, experiencing this particular configuration before it dissolves and becomes something else. The edge is dissolving. Between you and world, between now and then, between being and not being. The distinctions blur at close examination, revealing continuity, connection, the seamless flow of one thing becoming many things, becoming one thing again. The endless ocean of now. Imagine standing at the ocean's edge. Waves arrive, one after another, each one unique, each one following the same pattern. Roll, crest, break, recede. Again and again. Each wave is new. Each wave is also the same. The water molecules differ, but the pattern persists, eternal, repeating, reliable as breath. Time is like this. Moments arrive one after another, each moment unique, each moment following the same pattern, arising, being, passing, again and again. You stand at the edge of time like you stand at the ocean's edge, watching moments arrive, experiencing them, watching them pass. Wave after wave, moment after moment, the endless rhythm continuing, and like waves, no moment is truly separate from the ocean. Each wave is ocean, temporarily taking wave form. Each moment is time, temporarily taking the form of now. The ocean is always here. The waves come and go, but ocean remains. Time is always here. Moments come and go, but time remains. Or perhaps more accurately, there is only ocean, only time, and what we call waves and moments are just patterns, temporary forms the whole takes as it moves. You're standing in the eternal now, watching time express itself as moments, as waves, as the constant arising and passing that creates the illusion of flow. But there is no flow. There is only here, only now, only this eternal present taking infinite forms, creating the appearance of sequence, of past becoming future, of movement through time. In reality, nothing moves. Patterns shift, yes. Configurations change, yes. But the ocean itself doesn't flow. It's always here, always now, always complete. And you're not separate from the ocean. You're a wave, temporarily distinct, experiencing yourself as separate. But you are ocean, always were ocean, will always be ocean, even when the waveform dissolves. This is not metaphor. This is as close as language can come to describing what meditation reveals. The sense of being a separate self, moving through time from past to future, that's illusion. Useful illusion, necessary for functioning, but illusion nonetheless. What's real is presence, awareness. the field in which all experience arises, and that field is timeless, unchanging, eternal, not in the sense of lasting forever in time, but in the sense of existing outside time, prior to time, as the ground from which time emerges. You can rest here, in the timeless presence that you are. Not by achieving anything, not by going anywhere, but simply by recognizing what's already true. You are already here, already home, already complete. The waves will continue. Moments will arise and pass. Time will appear to flow. But you don't have to be swept along. You can rest in the ocean, in the timeless presence, watching waves arise without being identical to any wave. This is freedom. Not freedom from time, but freedom within it. Experiencing time without being bound by it. Living in moments without being limited to moments. Like standing at the ocean's edge. You're there in space and time, feet wet, salt air on your face. But you're also witnessing it all, present to the experience without being dissolved into it. Both perspectives are true. You are the wave, temporary and unique. You are the ocean, eternal and unchanging, not one or the other. Both, simultaneously. And in that recognition, something profound shifts. The urgency of time loosens. The fear of ending dissolves. Because what you essentially are was never born and will never die. It's prior to time, independent of time, unaffected by time. The wave will break. That's its nature. But the ocean continues, and you are ocean, expressing temporarily as wave, eternal even in your temporal form. So rest here, in the ocean, in the presence, in the now that has no beginning or end. Wave after wave will arrive and pass, let them. You're not any particular wave. You're what waves are made of, what allows waves to be, what remains when waves return to stillness. The ocean is still. Even as waves move across its surface, even as patterns shift and change, the ocean itself is fundamentally still, deep, calm, at rest. And that stillness is what you are, not the surface activity, not the waves of thought and experience, but the depth beneath, the presence that holds it all, the awareness in which all experience arises. This awareness requires nothing, achieves nothing, goes nowhere. It simply is, eternal and complete, requiring nothing to be different, accepting all waves equally, allowing all patterns to form and dissolve within its spacious stillness. You are this, not the person with history and future, not the collection of thoughts and memories and plans, but the awareness in which that person appears, the space in which that story unfolds, the presence that witnesses it all. And this awareness is timeless, has always been here, will always be here, prior to your birth, present through your life, remaining after your death. Not personal, not individual, but the fundamental ground of being itself. Rest here. You don't have to understand this intellectually. Just rest. Let the waves come. Let them go. Remain as the ocean, deep and still, allowing all movement while remaining fundamentally at peace. The gathering dusk of being light fades so gradually you don't notice until it's halfway gone. One moment it's afternoon, bright and clear. Then you look up and realize the sun is lower, shadows longer, the quality of light changed to something softer, warmer, preparing for evening. This is how time passes, gradually, imperceptibly, changing everything while you're not paying attention. You don't see the process, only the result. Suddenly you're older, the world is different, and you can't quite identify when the change happened. But it happened, day by day, moment by moment. Too slowly to perceive directly, but inexorable in its accumulation. And now here you are, in a different place, a different phase, wondering how you got here. This is the mystery of gradual change. It's invisible while happening, visible only in retrospect. You can't watch yourself age, can't perceive the cells dying and being replaced, can't feel time doing its work. You only notice the results, the accumulated effects of countless tiny changes, and there's mercy in this. If you could feel every moment of aging, every cell's death, every small loss, it would be unbearable, but you can't. Change happens below the threshold of perception, and you're spared the weight of witnessing it all. You get to live in the illusion that things are stable, that you're the same person you were yesterday, that the world is unchanging, and then occasionally you look up, notice the light has changed, realize time has passed without your permission. But this isn't tragedy. It's just time doing what time does, carrying everything forward, changing all forms gradually, too gently to hurt, too slowly to resist. And in this gradual change, there's time to adjust, to adapt, to become the person who fits this new phase of life. You don't change suddenly. You grow into change slowly, so gradually that it feels natural by the time you notice it. The light fades, evening comes, night follows, and tomorrow light will return, beginning the cycle again. But you will be different tomorrow, changed by today's experiences, aged by today's moments, transformed in ways too subtle to identify, but real nonetheless. This is okay. This is how it should be. Sudden change is violent, disruptive. Gradual change is gentle, allowing adaptation, permitting growth at a pace you can integrate. So don't mourn the fading light. Don't resist the gradual transformation. It's not loss, it's evolution. The natural progression of all things from one state to another, from one phase to the next. You were young once, that light faded. But a different light came, the light of maturity, experience, wisdom. Not better or worse, just different, appropriate to this phase. And this phase will fade too, into whatever comes next. You can't stop it, can't hold on to any particular configuration, but you can allow it, can flow with it, can trust that each phase brings its own gifts, its own beauty, its own appropriate light. The dusk is beautiful in ways that noon is not. The softness, the warmth, the way it makes even ordinary things look magical. This beauty is possible only because the light is fading, only because day is ending. Similarly, each phase of life has beauty specific to it, not despite change, but because of it. The particular quality of this time in your life exists only because you're not in a different time, only because you've arrived here through all the previous phases, so honor where you are. This particular light, this specific phase, this moment in the long arc of your life. It won't last, nothing does. But while it's here, it's worthy of appreciation, worthy of presence, worthy of being fully experienced before it too fades into whatever comes next. The dusk gathers, not threatening, not ominous, just the natural dimming that prepares for rest. And in that gathering darkness, there's peace, the peace of completion, of a day lived, of energy spent, of the natural cycle approaching its necessary end. Rest in this. Allow the light to fade. Trust that darkness is not ending but transformation, not loss but change of state, not death but the necessary precursor to tomorrow's dawn. Everything fades, everything returns, the cycle continues, reliable and eternal, carrying you through phases you can't control but can learn to trust. The light is changing, that's all. Just changing as it always has, as it always will, faithful to its nature, following patterns older than memory, completing cycles that have turned since before time began. And you are part of this. Not separate, not apart, but woven into the cycle, participating in the eternal rhythm of arising and passing, light and dark, beginning and ending that creates the fabric of existence itself. The last flight of swallows. Swallows gather on power lines in late summer, restless, preparing for migration, feeling the pull of distant places written into their genes. They know it's time to leave, though no one taught them. though they've never made this journey before, and then one evening they're gone. The power line's empty, the sky silent. They've left, flown south, following ancient routes to winter grounds thousands of miles away. This is instinct, wisdom older than individual birds, carried in bodies, expressed in behaviour. The swallows don't question it, don't resist. When the time comes, they go, trusting the knowing that moves through them. You have this too, not for migration, but for life's transitions. Something in you knows when it's time to leave, time to change, time to let go of what no longer serves. An instinct deeper than thought, older than personality, carrying wisdom from ancestors who face similar transitions. But unlike swallows, you can resist this knowing. You can ignore the restlessness, the sense that it's time to move, time to change. You can cling to what's familiar even when everything in you is ready to migrate, and this creates suffering. Not the transition itself, but the resistance to it. Fighting what your deeper self already knows, trying to stay when everything in you is preparing to leave. Swallows don't do this, they trust. When the pull comes, they follow. When instinct says go, they go. No second guessing, no fear, no resistance. Just action, natural and appropriate, aligned with deeper rhythms. What if you could be like this? Not impulsive, not reckless, but trusting. When the deep knowing says it's time to change, trusting that knowing. When something in you is restless, recognizing it as guidance rather than problem. Because that restlessness is not random. It's your instinct, your deeper wisdom, indicating that you've outgrown current circumstances, that it's time to migrate to new territory, internal or external. But you've been taught not to trust this, to plan, to analyze, to decide rationally. And these skills are valuable, but they're not the only way to know. Sometimes the body knows before the mind. Sometimes instinct is wiser than analysis. Swallows don't know why they migrate. They don't understand seasons, weather patterns, food availability. They just feel the pull and follow it. And they arrive exactly where they need to be. You can't live purely on instinct. Human life is more complex, requiring thought and planning. But you can honour instinct when it speaks, can recognise that the restlessness, the dissatisfaction, the sense that something needs to change, these aren't problems to solve, but signals to heed. And when you honour them, when you allow the migration that wants to happen, you often find yourself exactly where you need to be. Not because you planned it perfectly, but because you trusted the deeper knowing that was guiding you all along. The swallows return in spring. Same birds, same power lines, completing the cycle. Migration isn't ending, it's movement within a larger pattern, leaving and returning, following rhythms that sustain life. Your transitions are like this too. Not departures into the unknown, never to return, but movements within larger patterns, leaving one phase to enter another, trusting that what you're leaving will be there if you need to return, but knowing that you won't need to return because forward is where life is taking you. The power lines are empty now, the swallows are gone, and in their absence there's space for winter's birds, for the species that thrive in cold, that fill ecological niches the swallows left behind. Similarly, when you leave, when you move on, you create space for what comes next, not just for you, but for others. Your departure allows new arrivals, new possibilities, new configurations that couldn't exist while you remained. So leaving isn't selfish, it's necessary, part of the pattern, part of the cycle, part of how life renews itself through constant movement, constant change, constant migration from what was to what's becoming. The swallows will return. And you will too, in a sense, though transformed by the journey, changed by what you experienced while away. The returning is never a return to exactly what was. It's a return as someone new to a place that's also new, completing a cycle that advances rather than merely repeating. Trust this. Trust the pull. Trust the restlessness. Trust that when it's time to migrate, something in you knows even if your mind doesn't understand yet. The swallows are already flying, hundreds of miles away by now, following routes they've never travelled, finding places they've never seen, guided by knowing deeper than thought, older than memory, reliable as the seasons themselves. The breathing of mountains. Mountains breathe. Not like you breathe, not air in and out. But they breathe nonetheless, slowly, on timescales so vast that human lifetimes are heartbeats in the mountain's day. Rock expands in warmth, contracts in cold. Freeze-thaw cycles crack and shatter stone. Each season, each century, the mountain changes, breathing in and out over millennia, alive in ways we rarely recognize. And deep beneath, tectonic forces push upward while erosion wears downward. The mountain grows and shrinks simultaneously, building and dissolving, birth and death happening together in slow motion. Too slow to see, but constant, real, ongoing. This is deep time, the time of geology, of planetary processes, of changes so gradual that they seem like stillness, but are actually profound transformation happening at mountain pace. Everything breathes at its own rhythm. Cells, milliseconds, humans, seconds, trees, minutes in the sway of branches, years in the adding of rings, mountains, millennia, planets, hundreds of millions of years, galaxies, billions, each scale equally valid, equally real, each one breathing in its own way, living its own timeline, experiencing duration in its own rhythm. You breathe quickly compared to mountains, but you're breathing. That makes you kin to mountains, to stars, to all things that rise and fall, that inhale and exhale, that cycle between states in rhythms of their own. And perhaps consciousness breathes too. Periods of waking and sleeping, activity and rest, incarnation, and whatever lies beyond incarnation. Breathing into life, breathing out to death, the ultimate rhythm, the deepest cycle. Mountains teach patience. They show that vast change happens through tiny increments, that persistence matters more than speed, that the slow breath is still breath, still movement, still life. When you're impatient, when you want change now, remember mountains. They rise millimeter by millimeter, grain by grain, patient beyond human capacity, yet they rise nonetheless. The Himalayas are still growing, pushed upward by India's slow collision with Asia, increasing in height by about 5 millimeters per year. Imperceptible to any observer, profound over time. This is how real change happens, not in dramatic leaps, but in patient accumulation, in the reliable daily breath that continues whether you notice it or not. Your breath is like this too, each breath tiny, insignificant. But breath by breath, you've lived your whole life. The accumulation of millions of breaths is you, alive, present, continuing, and each breath is complete. You don't need more than one breath. You just need this breath now, and then the next breath when it comes, and then the next. Mountains breathe this way, one geological moment at a time, one freeze-thaw cycle, one grain of sand eroded. Not worrying about the next 1,000 years, just being mountain now, breathing mountain breath, existing in mountain time. You can live this way too. Not worrying about the next 1,000 moments, just being here now, breathing now, existing in your own proper time. And in this, you're not separate from mountains, from stars, from galaxies. You're all breathing together, each at your own pace, all part of the same cosmic respiration. The universe breathing itself through countless forms at countless scales. The mountain breathes. You breathe. All breathing together, all part of the same process, the same life, the same presence expressing itself through infinite variations. And in this recognition, you can rest. Not separate, not struggling alone, but breathing with everything, part of the vast community of beings that spans from atoms to galaxies, all breathing, all alive, all held in the same eternal presence that makes breath possible. The return to quiet words are running out. There's less to say now, less that needs saying. The journey through time has brought us here, to this quiet place where concepts fade and presence remains. What is time? We've explored this question from many angles: physics, philosophy, psychology, meditation. And perhaps you've noticed, the more we've examined time, the more it's dissolved, revealed itself as not quite what we thought. Not a river flowing, though it feels that way. Not a dimension exactly like space, though physics treats it as one. Not something external pushing you forward, though you experience being carried. Maybe time is more like a space than a force, a space in which change happens, in which experience unfolds, in which the universe expresses itself through continuous transformation. And maybe you're not moving through time so much as time is moving through you, expressing itself as your experience, your memories, your anticipations. You're not separate from time. You're time taking the form of awareness, the universe experiencing its own unfolding through your eyes. This is speculation, of course, words pointing towards something that can't quite be captured in words. But maybe that's appropriate, because time, finally, is not something to understand intellectually. It's something to experience, to live, to be present for. And that presence is available now, not later, not after you've understood everything. Now, this moment, this breath, this simple fact of being alive, aware, present. The questions we've explored, they're interesting, but they're not necessary. You don't need to understand time to experience it. You don't need to solve its mysteries to live fully within it. You just need to be here, present, aware, breathing. And in that simple being, time reveals itself not as problem to solve, but as the medium you exist within. Like fish in water, like birds in air, you're in time, of time, expressing time through your existence. This is enough. This simple presence, this basic awareness, this fundamental being. Everything else, all the complexity, all the questions, their elaborations on this simple fact. You exist now, aware of existing. And that existence has been happening in time. The you of childhood, the you of yesterday, the you of this moment, all different configurations of the same continuing presence. Time is the dimension that allows this continuity, this persistence through change. So time is not your enemy. It's not stealing from you, not running out too fast, not oppressing you with its relentless forward march. Time is the gift that makes your existence possible, the frame that allows you to have a story, a history, a future. Without time, you couldn't be. Without change, you couldn't grow. Without moments succeeding moments, you couldn't experience life as a journey, as development, as meaning unfolding. So maybe the question isn't how to master time, or escape time, or save time. Maybe the question is how to live fully within time, accepting its gifts, flowing with its rhythms, honouring it as wisdom. And the answer, if there is one, is simple. Be present, not rushing toward future, not clinging to past. Just here, now, aware, alive, grateful for this moment that contains everything you need. Time will continue, moments will arise and pass, change will happen. All of this is guaranteed requires nothing from you. Your only task, if there is a task, is to be here for it, to witness it, to experience it, to say yes to this moment, this breath, this life as it unfolds. Everything else takes care of itself. The deep settling. And so we arrive here, at the end of words, at the beginning of silence. The story of time has been told, or at least attempted, and now there's nothing left to do but rest. Rest in time. Rest as time. Rest with time. Let the questions go. They've been interesting companions, but you don't need them now. Let them dissolve, float away, return to the silence from which they came. What remains? Just this, just now, just presence, aware of itself, requiring nothing, complete as it is. Your breath continues, gentle and reliable. Your heart beats, steady and faithful. Life continues its work, automatic and gracious, requiring nothing from your conscious mind. You can relax completely. Let everything be handled by the deep wisdom that keeps you alive without your effort. The wisdom that beats your heart, that digests your food, that heals your wounds. It knows what to do. It's always known. And in this relaxation, this letting go, time becomes gentle. No longer urgent, no longer pressing, just unfolding, naturally and easily, like water flowing downhill, like clouds drifting across sky. You're part of this flow, not controlling it, not resisting it, just allowing it, riding it, resting in it like a leaf floating on a stream, carried without effort, moved without struggle. Where is the stream going? It doesn't matter. The stream knows, and you're in the stream, of the stream, being carried by the stream. Trusting is easier than struggling. Allowing is easier than resisting, so allow. Let time carry you. Let moments unfold. Let whatever's happening happen without needing to change it, fix it, understand it. Just this. Just now. Just being. Nothing else required. Nothing else needed. Just the simple fact of existence. Awareness. Presence. And in this simplicity, something profound. The recognition that you are enough, exactly as you are. That this moment is enough, exactly as it is. That life is enough right now, complete, lacking nothing. The search can end, not because you found something, but because you've recognized what was always here. Presence, awareness, being, the simple fact of existing, conscious, alive. This was never lost, so it didn't need finding. It was just overlooked, ignored, covered by layers of thought and worry and planning. But underneath all that, it was here, is here, will always be here. You are here. Not going anywhere because there's nowhere to go. Not becoming anything because you already are. Just here, just now. Just being what you are. And what you are is enough. More than enough. Complete. Perfect in the sense of whole. Lacking nothing. Requiring nothing to be different. This is the gift of time. Not duration. Not more moments. But this moment, complete in itself, containing everything needed, offering everything valuable. One moment, fully experienced, is worth more than a lifetime of moments rushed through, ignored, resisted. So rest here, in this one moment. Let it be enough, because it is. It always was. It always will be. Time continues. Let it. Moments arise and pass. Let them. All of this happens naturally, easily, without your effort. Your only role is to be present for it, to witness it, to allow it. And in that allowing, in that presence, in that simple being here now, everything is complete. Nothing lacking, nothing needed. Just this, just now, just breath, just peace, just rest.